So good morning once again and welcome to the Datastage 11.3 certification training course. Let me introduce myself first. So my name is Kriti and I'm going to be your trainer. I have 15 years of experience in data warehousing and most of it is in Datastage. So in this course, we'll be focusing on the important concepts and Datastage features that form the basis of the Datastage certification exam. We'll also be practicing with sample exam questions along the way, and there will be one practice test at the end of this course. So let's take a quick overview of the Dataset certification exam before we go on into the concepts that we need to learn. So Datastage 11.3 is the latest version of the certification exam, and it will have 64 questions, and you need to answer 41 correctly to pass the exam. You'll get 90 minutes to give your exam or take your exam. And there's no negative marking in the exam. The questions are multiple choice types and there might be one or more correct answers. Now the questions are based on these below 11 sections broadly, and they have divided the percentage or the weightage of each section. So you have a particular percentage for configuration, metadata, persistent storage, and so on. I'll put the link to this as well in the chat window so you can go through it yourself and see. So in our course as well, we are going to cover by these topics. We'll be covering all these topics. We'll be touching upon the important concepts that are needed for each of the topics, and we'll be practicing, as I mentioned earlier, some simple questions along the way as well. The first topic that we're going to cover today is from the parallel architecture section. So before we go into designing the jobs, we need to understand the environment, the metadata, the parallel architecture, all those capabilities of Datastage, and there are a lot of questions around these topics. So Datastage we know has the feature of parallelism, and that is its most important feature. So to have that feature, it needs to be installed in the parallel processing environments. Now, the different kinds of parallel processing environments. An environment is basically defined by your system resources, your hardware, your network configurations, and so on. So in general, there are three kinds of environments. You can have a single CPU system, you can have a multiple CPU system with shared memory and disk, and then you can have a shared nothing system. So you have multiple CPUs and all of the systems have their own dedicated memory and disk space. Now, because you want to exploit the parallel features of Datastage, it will mostly be installed on either the SMP systems or the grid or MPP systems. The SMP systems, as we can see here, are the symmetric multiprocessing systems. In the SMP systems, you have multiple CPUs, but they use a shared disk and they have a shared memory. On the other hand, if you have an MPP or a grid cluster system, then you have multiple CPUs and they all have their own dedicated memory and dedicated disk space. So obviously they are much faster than the SMP systems, but because of the large number of resources and the dedicated memory and disk space that is used, they're also more expensive. So depending on your requirement and how much resources and how much money is available, the system would be your system would be chosen, whether you need a SMP system or an MPP or grid system to install Datastage. There are two types of parallelism in Datastage. The first one is pipeline and the other one is partitioning. So these are the two kinds that enable all that fast processing of data in Datastage. Now, pipeline parallelism, if you take a look at this figure, the first job that we see is an extract, transform, load job. So the first stage is the source, then you have a transformer stage that will perform some derivations, and then we have a target stage, which is a database stage. Now this job is running sequentially. So this job is running with no parallelism. How does it process in the backend when the job is running with no parallelism? In this case, let's say there are 10 records that need to be read by the source Oracle stage, and then need to be transformed and then loaded to the target table. If there's no parallelism, then the source stage would read all the 10 records. The transformer stage would wait till the source stage finishes reading those 10 records. Once the source stage has finished reading all the 10 records, then the transformer stage would start processing those 10 records. Once the transformer stage has finished processing all those 10 records, only then the target stage will start to load those 10 records. So the time taken here is the time taken to read all those 10 records plus the time taken to process all those records, and then the time taken to load all those records into your target area. But what if there was some kind of parallelism and pipeline parallelism? Pipeline parallelism means that there would be a regular inflow and outflow of data from each of the stage. So in this case, out of those 10 records, the source stage will start reading the first record. Once it has completely read the first record, it will pass that record to the next stage, which is the transformer stage in our case. Simultaneously, it will start reading the second record. So now in this case, the source stage is working as well as the transformer stage is working. So the source stage is reading the records, the transformer stage is transforming the records all at the same time. At the same time, as soon as the transformer stage has finished transforming one record, it will transfer it to the target stage to load it to the database table. So all the stages are working simultaneously. So pipeline parallelism is that there is a data that flows from one stage to another continuously. We do not wait for one stage to complete processing of data for the next stage to start processing that data. So the time taken in this case is highly reduced compared to the time taken in the case when there was no parallelism. The key features of pipeline parallelism, as we understood from the previous slide, therefore, were that the extract, the transform, and the load processes are executing simultaneously. The downstream process, which is any processing that happens by the next stage, starts while the upstream process is still executing like a conveyor belt moving from rows from process to process. So we can take this analogy of the conveyor belt to understand how the data flow is happening. Sorry. The advantages of this kind of parallelism are that there's reduced disk usage for staging areas and keeps all the processors busy. This means that because the data is continuously flowing at a particular point of time, there's less data being stored in the shared memory or in the scratch disk or the temporary disk or any kind of hard disk, and that is why there's reduced memory as well as disk usage. And all the processors are busy because something is happening at each stage at all the time. Whereas in case of no parallelism, uh, the whole hard disk would be needed to store all those 10 records for each stage. So therefore, it results in increased disk usage. It has limits on scalability. So how much you can improve the pipelining process, there would be limits, again, depending on your hardware resources, how much memory you have, how much disk space you have, depending on all those things, there would still be limits on all these capabilities. The next kind of parallelism that Datastage offers is known as partition parallelism. Now, if we have worked as a developer in Datastage, we know this kind of parallelism very well because in most of the stages, we need to explicitly define the kind of partitioning that we want to perform for the stage to work correctly. Partition parallelism, as we can understand from the figure, is basically dividing the incoming data into multiple partitions or multiple streams. All those streams are then worked upon simultaneously. So the more the number of partitions or the more the number of streams that you divide your data into, the faster would be the job. So this is partition parallelism. So here we are simply dividing the incoming stream of data into subsets, and each of the partition is being processed separately. All the same operators and all the same processing is being done on each of the partition. it has near linear scalability, which means that you increase the number, you keep on increasing the number of partitions, and as you increase the number of partitions, the degree of parallelism will increase. The most advantage that we can get out of partition parallelism is when the data is equally distributed across all the partitions, so that the partitions are taking approximately equal amount of time to perform their processing. And in that case, let's say there are 10 records and there are 5 partitions and 2 records are distributed across each of the partition, then the processing would take an optimum amount of time. But let's say out of those 10 records, one partition has got 4 records, another partition has got 1 record, and so on. So the data is now unequally distributed. So obviously the partition that has 4 records would take more time for processing. The one with the 1 record would have completed its processing faster. So the overall advantage that we would gain from this technique would be less as compared to when the data would have been equally partitioned. So our aim should be to try to partition the data equally if there is no other specific requirement, and we'll see more details when we do the kind of partitionings. Now, when you combine the pipeline and partitioning or the partition parallelism, that is when you get a Datastage parallel job. So any Datastage parallel job that you design is using both of these kinds of pipelining and partition parallelisms. And this is how the processing at the back end would look like, where the data is continuously flowing from one stage to another, as well as there are multiple instances of each stage that are running across each partition, and the data has been divided across those partitions, and the processing is happening across all of those partitions. Now, the next topic that is very related to this partitioning or the parallel architecture of Datastage is the configuration. The configuration file is the one that defines your degree of parallelism in the job. And the kind of parallelism that we are now talking about is mostly partition parallelism. So that is the one that is defined by how we define the resources in the configuration file. So configuration file, the first thing that a configuration file defines are the number of nodes. Then it defines all the resources which are allocated to all those nodes. And we'll see more details very soon. Now the number of nodes, if you look at this figure, here we have 4 nodes, 1, 2, 3, and 4. That means your partitioning, the degree of parallelism would be based on the 4 partitions or the 4 nodes that we have in the configuration file. If we would increase these number of nodes to, let's say, 5 or 6, the degree of parallelism would increase. So nodes are nothing but the partitions, number of partitions that we are talking about. So number of nodes is equal to number of partitions. Now, the important advantage of a configuration file is that when your system resources change, so let's say now there's a requirement to move your Datastage jobs from one server to another server. Now, the second server has different system configuration, different hardware configuration. So in that case, there would not be any need to change your Datastage code. You can just change the configuration file accordingly, define the number of nodes as suited to your second server, define the number of resources that can be allocated to those nodes. So just change the configuration file, keep the Datastage code as it is, and move it to the second server. Whenever you run a Datastage parallel job, the configuration file is the one that is read at the very first instance, and that is included in the startup time of the Datastage job. Based on the configuration file, whatever is defined in the configuration file, the system preps up the resources that would be needed for the execution of the Datastage job. Nodes, as we mentioned earlier, are the partitions. On the backend, if you think about, they are basically the locations on which the engine runs the generated operators. Now, the operators that we're talking about here are the OSH operators. So just a couple of minutes Ahead, we have some slides on the OSH and where we'll see more details of how the OSH of a Datastage code is generated. All these nodes are logical. So you have your physical CPUs. On top of those physical CPUs, you define some nodes. So one CPU can have one node, or one CPU can have multiple nodes. The node in itself is a logical entity. So it's a logical node. It's not your physical CPU. It's a node name is a logical name pointing to a logical entity on your CPU. So one CPU can have one or more logical nodes. The format of a configuration file is simply like a text file. So it's a simple text file. It is stored on the Datastage server. You have the capability to change it, to view it. To access this, you can define multiple configuration files for the same server as well. So let's say there's a requirement for one job to handle a large volume of data. So we want it to be running on multiple nodes. We want it to be running on 4 nodes. Whereas other jobs do not handle that much amount of data, and we do not want to be using the 4 nodes for running our Datastage jobs. For those cases, so we can have another configuration file where we define only 2 nodes. So we can have multiple configuration files. The one that we're going to refer is determined by the value of the environment variable, which is $apt_config_file. So whatever value you pass to this config file environment variable, that would decide which configuration file the job needs to read to execute. The primary elements of a configuration file are the node names, which we define, which are the processing nodes, which are basically the number of partitions that your job would execute on, and they can be same as the physical nodes, but they are more of logical nodes. So one CPU, one processing unit might have one node, or it might have multiple nodes. Fast name, or we'll see, fast name is again the name that the system refers to, the hardest connection on the system refers for that node. Pools are simply groupings, and resources are simply something like disk and scratch disk space and buffer disk space and so on. So we'll see all this in more details over here. So node name, as we can see again, is a user-defined name. So node name could be anything. You can define it as anything in your configuration file. You can define it as N0, N1, N2. You can define it as ABC. You can define it as 1, 2, 3. Whatever you want, you can define it as anything. Fast name is the name of the computer system upon which a node is located, as referred to by the fastest network on the system. That is a fast name. A fast name is specified for each of the processing node. Now, it is a name that is referred to by the fastest system. If they're running on a single system, so your SMP runs on a single system, therefore, all the processing nodes that are there in an SMP will have the same fast name. The fast names are the one which are then accessed by Datastage to open connections for input, output, data, processes, and so on. The pools are of two types. They can be node pools and resource pools. They're basically used to logically group the nodes. So you have 4 nodes in your configuration file. You want to group 2 nodes together. So now you want to use only those 2 nodes for a particular purpose. Then that would be one pool. The other 3 nodes can be grouped in another pool. So nodes can appear multiple times in multiple pools. Resource pools are groupings of the resources, like the hard disk resources, your scratch disk resources, your buffer disk resources, your short disk resources, and so on. Now, all throughout, there's something called the default pool. So whenever you have 2 double quotes, that means it's a kind of an empty string that denotes a default pool. So all the nodes are assigned to the default pool. not all the nodes, all the operators can use whatever nodes are defined in the default pool. So if you define node N1, N2, N3 in the default pool, then all the operators are basically the OSH operators and data stages are converted to in the backend. So basically we are saying that all the data stages can use all the nodes that are defined in the default pool, and same with all the resources which are defined in the default pool. So all the stages are free to use any of the nodes or any of the resources which are defined in the default pools. Resources are of two types, disk and scratch disk. Now a look at this sample configuration file will make the all these terms that we have just learned, it would make it easier to understand. So this is a sample configuration file that has one node, as we can see. And the name of the node is node1. And this is the format in which a configuration file has to be written. So you need to have those curly brackets, then the node name, and so on. So you give a name to the node, and that can be any name that you choose. Then this is your fast name for this node. And as we learned earlier, it is the name that is referred to by the fastest network on the system. Now this node, we have defined some pools for this node, and it belongs to the default node pool, as can be indicated by the double quotes over here. It also belongs to a node pool that again has the name of node1. So we have created a new node pool. It's known as a named node pool, and we have given it the name of node1. This node has the resource disk. This is the path of the hard disk or the resource disk, and that belongs to pool's default pool. It is also assigned another resource disk which has this path on your server, and the pool is known as big data. So again, in this case, this is a named disk pool. Then you have a scratch disk. Scratch disks are basically used for temporary storage of data when you run out of the disk space and you need some extra hard disk space to perform your operations. That is when the scratch disk is used. So there are two scratch disks assigned to this particular node. One of them belongs to the default node pool and the other belongs to a named node pool. So what we are basically saying here is that this is one node in a configuration file, and these are the resources available for that node. Now all the resources which are assigned to the default pools, which can be identified by these empty double quotes, these can be used by any kind of data stages they can use. But let's see the last scratch disk. So that belongs to the pool sort, that is a reserved name pool. So there are some reserved names like sort and buffer. So because they specified this scratch disk to belong to the sort pool, sort stage is the one that would be using this scratch disk and not the other stages. So any kind of sorting stage, sorting operation, a sorting operation can be performed by the other stages as well, because there's a feature in the stage editor for the other stages. You can do an in-stage sort. So whenever there's a sort operation happening in the data stage job, it can go and use this resource scratch disk. So resource pools, as we just saw, they allocate the storage to these pools. The default pool, as we saw earlier, can be used by any of the stages in the job, but the operators can be constrained to use resources assigned to specific name pools. So you can actually ask a stage to run on a particular resource pool, and we'll see how we can do that. The sorting resource pool. So we saw earlier that there was node 1 in the sample configuration file that was specifically the scratch disk was assigned to the sort pool. So whenever there is a specific pool by the name of sort, those are the resources that can be used for sorting. That scratch disk is available for sorting. Now that does not mean that the sort operator cannot use the default disk pool. It can use the default disk pool as well, and it also has the option to use the sort disk pool. So there's a particular order in which it actually goes about looking at these resource pools. It looks first for the scratch disk resources in sort pool, then it looks for resources assigned to the default disk pool. So there is this particular order every time a sort operator is needed for a Datastage job and it needs scratch disk resources to execute. It would first go to the node pool that was to the resource pool that was defined by the name sort, and then it would go to the default disk pool. So this is the bigger configuration file. As you can see here, there are 4 nodes in this configuration file. Now, the first thing that we should observe, excuse me. Now, the first thing that we need to observe here, and because there are questions around that thing, is whether if you look at this configuration file, you think it is a SMP system or a cluster or an MPP system. So the way you can tell that is basically looking at the fast names. So there are many questions in the certification exam, and they are of this type that whether this configuration file, they'll give you a snapshot of the configuration file and ask you whether the system is a SMP system or if it is a cluster system or a grid system. The way to tell that is by looking at the fast names. Now we saw earlier that in a SMP system, the fast names would be the same for all the nodes. So if the fast names are different, as are in this example, that means that it is running on a grid it is running on a grid or a cluster system. So we can see that there are 4 nodes over here. Node 1 has the fast name of S1. It is assigned to these node pools. So there is a default node pool that is assigned to. Then these are the named node pools N1 and S1. And this is a reserved named node pool, which is called sort. And this can be used by the sort operator. So this node can be used by the sort operator. Then you have 2 resource disks assigned to this, which belong to again to the default pool. And then you have a resource scratch disk, which is assigned, which is again a reserved resource pool for the sort operator. So similarly, if we look at node 2, then we have the fast name S2. It belongs to the default pool named pools N2, S2, and app1. It is assigned the resource disk which belong to the default pool, and so on. So this is basically how you interpret a configuration file. And there would be many questions around the way you interpret the configuration file. So it's very simple. First is your node names, number of nodes, define the number of partitions that would be in their job. So if they ask you that there is a transformer stage in the job and it is using this configuration file which has 4 nodes, then how many instances of the transformer operator are processing at the back end? Then those instances are equal to the number of the nodes that are defined in this configuration file. So that would be the 4 instances or 4 processes running at the back end. Then they'll ask you questions around these named pools or basically the reserve name pools. So they'll ask you which resource disk space can be used by the or would be used by the sort operator and so on. So you can keep an eye out for these reserved names. So there's also one name called buffer, which is used by the buffer operator. So as sort is a reserve keyword, buffer is also one of the reserve keywords. Okay. Now, we saw earlier that there was an option to restrain some of the operators, some of the stages to run on particular node pools or specify the node constraints for some of the stages. So let's say we have four nodes in our configuration file. So these are the 4 nodes in our configuration file, but we want a sort stage to run on only the sort pool or use only the sort scratch space, or let's say app1. We want to constrain it to app1. So app1, you can see here, app1 is one of the named node pools. It has 3 nodes in it because node N2 also belongs to app1, node N3 also belongs to app1, and node N4 also belongs to app1. So app1 has nodes 2, 3, and 4. So if we constrain a particular stage to run only on node pool F1, it will be using these three particular nodes. Now, what is the need to actually go and constrain any stage to run on some particular node pools or particular resource pools? The need is that we can define the node appropriately or as per the requirements of that particular stage. So let's say we have a resource intensive stage. We are expecting that a lot of derivations, a lot of calculations, a lot of aggregations and computations would be done by some particular stage. Then we can create a node and specify or allocate it more amount of scratch disk or a larger resource disk. So those capabilities we can vary, which are assigned to a particular node, and then we can go and constrain that stage to run on that particular node or particular node pool. So that is the advantage of constraining a stage to run on a particular node pool or resource pool. So this is a sort stage that we have taken an example of here. If you go to the sort stage and go to the advanced option over here, you'll see that the configuration file here is defined. And then there are these two multiple options. You have node pool and resource constraints and the node map constraint. In the node map, you can choose the particular node that you want the job to run on. And as you can see, let's see from the other figure, the first option, the node pool and resource constraints, as you can see over here. Here you can choose what kind of resource do you want to constrain to a node pool or to resource pool. If you want to constrain to a node pool, you have to put the name over here. If you want to constrain to the resource pool, then it will give you further drill down of the type. So whether you want to constrain to the disk resource pool or the scratch disk resource pool, and you have to put the name of that resource disk or scratch disk pool over here. So that is how you can constrain these particular options. So you can constrain this particular stage by going to the advanced setting and selecting the node pool and resource constraints. Now, in an example earlier, this particular area was disabled, and the reason was it was giving at the top that multiple node pools should be defined in your configuration file. So in the configuration file, in that example, there were no pools that were defined, and that's why only default pools were defined, and that's why it was not giving this particular example. The other option, as we saw, is basically to constrain it to a particular node. So you do not need to constrain it to a particular node pool because you have not defined any node pools in your configuration file. Then you can go and even constrain it to a particular node, so node 1 or node 2. So let's go back to the previous example and see once again. So if we go over here, go to the sort stage advanced tab in the stage editor. And here, sorry, go back. Okay, let me pause over here. Okay, so your configuration file is default, and this option is grayed out. To use resource constraints, you must define multiple pools in the configuration file because we did not define multiple pools. But in the node map constraint, you can simply map it to one of the nodes. If you do not have any pools defined in your configuration file, you can just go to the node map constraint, and we have defined two nodes in the configuration file for this case. So you can constrain it to either node 1 or node 2 and so on. Now, how you can create this configuration file, how can you edit this configuration file? It's very simple. You have something called a configuration editor, which is available right in your Datastage designer window. So you just need to go to tools and click on configurations. You can just paste you can use a default configuration file, which is always there in a Datastage installation. You can use it to manipulate and change your number of nodes and things like that. You also have an option to check the syntax and so on for your configuration file. So let's take a look over here. So you go to tools, you choose configurations, and then you get to this dialog box where you can define your configuration file. So you already have some configuration files over here, and you can define your own configuration file as well. So this is a kind of configuration file where you have the node names, first names, and some resource disk and scratch disk defined over here. And then at the bottom, you can see there are options to check and close. So you can select your configuration file, and if you click on the check configuration option, then there will be some output. It would tell you if there is some syntax error. So this is the easiest way to edit a configuration file in your configuration editor. Now, this configuration file can actually be viewed in multiple places. It can be displayed in the job log. So whenever you run a Datastage job, and if you go and take a look at the job log that is generated after the Datastage job execution, then there would be a message of the kind information in your Datastage job log, and that would have the details of your configuration file. So these are some simple questions which are related to the topics that we have covered. And these are the kind of questions that will be asked in your certification exam. And as I mentioned earlier, these are multiple choice questions which can have one or more than one correct answers. So this is one of the questions. Let's see if we can get this question answered correctly. So the question is, which three privileges must the user possess when running a parallel job? So you have various options. You have something called an APT awk home. So for this, you need to understand what is an APT awk home. It's basically an environment variable, again pointing to your Datastage directories where the configuration files and other things needed for the execution of a Datastage job are stored. And other things I think we already know. We know disk spaces and scratch disk resources and so on. So they have already specified that we have to choose three correct answers over here. So three options are correct here, and which are that the read access to APT or home. So whenever any job is being run to any user ID, that user ID must have a read access to APT or home. And we only need a read access because we need to read all those environment and configuration files that are needed for the Datastage job to be compiled and executed. Then the other correct answer is execute permissions on local copies of programs and scripts. That's self-understood. So any kind of script that you're using in a job, so Datastage job has an option to use Unix shell scripts, before job routines, after job subroutines, and so on. So any kind of files that you're using, any kind of local copies of programs, you should have complete access on them. And then you need read and write access to the disk and scratch disk resources, because all the stages which would be converted into operators in the backend of your Datastage job would be communicating with the disk and the scratch disk resources. So you should have the right access. So the right access is important over here. Then the two incorrect answers that we see, the first one is that there should be read-write permissions to the Unix etc directory. So that doesn't really make any sense. You don't have anything important over there, so we do not need the Unix etc directory permissions. And the APT Orcom write permissions we do not need, because we're just executing the Datastage job. We're not changing any configurations or any environmental parameters. So we will not be needing the write permissions, and any Datastage user in itself would not be having the write permission, because they will not have access to change the configuration files or the environment variables as such. The next job, so the next question, as you can see, these are big questions. They give you a scenario, and then you have to go through the multiple options that they have provided and select the correct answer. So it takes some time to read the questions and understand them, and then you can choose the options correctly. But they do help you by saying that you just have to choose two options. So they do specify that there are two options that need to be chosen over here. So the job is, a job contains a sort stage that sorts a large volume of data across a cluster of servers. So cluster of servers, which means it's either an MPP or a grid cluster system. The customer has requested that the sorting be done on a subset of servers identified in the configuration file to minimize impact on database nodes. Which two steps will accomplish this? So we just saw that we have an option to restrict some stages to run on particular node pools or resource pools. So that is the option that they are talking about here, because they are asking us to limit the sorting operation to be done on a subset of servers identified in the configuration file. So that is the clue for you. And when you go and read the options, you'll find out that the correct options would be to define a non-default node pool with a subset of nodes in your configuration file. So that would be your first step. And then you have to specify the appropriate node constraint within the sort stage. That would be your second step. So they're not in the right order, but these are the two right options that you would need to select. Now, another question, a job reads from a dataset using a dataset stage. This data goes to a transformer stage and then is returned to a sequential file using a sequential file stage. So we have a dataset stage as a source, then a transformer, and then a sequential file stage as a target stage. The default configuration file has three nodes. The job creating the dataset and the current job both use the default configuration file. How many instances of the transformer are running in parallel? So because it has three nodes and the default configuration file is being used, the transformer has not been constrained to run on any particular node pool or resource pool. That means it is using the default configuration with the three nodes itself, and therefore the correct answer would be 3. So the number of nodes that you have in your configuration file, it is defines the number of the degree of parallelism in your job, defines the number of instances of the stages that would be executing in the backend. So 3 instances of transformer because there were 3 nodes in the default configuration file. Now, there are also questions where they give a snapshot of your configuration file and then ask you to answer some questions. So the question here is that in this exhibit, what is big data? So now if we take a look at this configuration file and try to search for the word big data, we can see that it is over here. So this is big data and this is a particular resource disk. So this is a named resource disk pool. And we can also see that the resource disk for node N2 is also assigned to the big data resource pool. So we can see that this is a resource pool where the resources from node 1 and node 2 are assigned. So if we look at the options, you have resource pool, resource node, and node pool. So it's obviously the answer is A, which is a resource pool. Now let's move on to another related topic, which is metadata. So we have seen parallel environment, we have seen some part of configuration, and now we move on to the metadata. Metadata is basically OSH. What is OSH? OSH is your orchestrate shell language, which is basically what a Datastage job is converted into at the backend, or whenever you execute a job, that is what a job gets converted into, and that gets then converted into an executable file that is executed when you run a Datastage job. All the code is a combination of OSH and C++. And why are we mentioning C++ here? Because a transformer stage in a Datastage job is one particular stage that needs a C++ compiler. So you need to have that installed on your server, and only then you can use a parallel transformer stage, not a basic transformer stage, which is a server-side job stage. So whenever you design a Datastage job, at the back end, the code would be generated, which would be an OSH code plus the C++ code. OSH is nothing but a scripting language that can be turned into a code executable. So when this code is generated, the first thing that Datastage does, so you have an option to compile a Datastage job, and what is happening at that particular point is that it is validating the link requirements, your mandatory stage options, which should be prescribed. So if you use a sequential file stage and you do not give the file name option, you don't put a value there, then the compilation will result into an error. It validates the transformer logic, so sometimes it will give you errors if you've not handled null or something in the transformer and some other mandatory requirements. Then it generates an OSH of your data flow that is happening into your job and the particular stages that you have used. All the stages are compiled into C++ operators or the OSH operators, and table definitions are compiled into schema. So schema is a part of OSH, which we'll just see a couple of slides down. It generates transform operators for transformers. So again, C++ source code, then into C++ operators. And if you use any particular build stages, they have to be manually compiled in the job before you use them in the job. So all the build stages have to be compiled separately. So when we are using this terminology, the first thing that we need to remember is that all the stages on our data stage job designer window are converted into something called operators in the OSH when the OSH is generated. So let's see more details over here. Okay, so before that, where can you view this OSH? This OSH is available at multiple places for you to view. So OSH is visible in the job properties. If you go to the job properties on Datastage Designer window, you can see the OSH. You can see it in job log. You can see it in Datastage log, in the table definitions, everywhere. But you need to enable viewing of the generated OSH in your Datastage administrator to be able to see the OSH. And you simply have to go to the administrator in the parallel jobs. You have to select the option generated OSH visible for parallel jobs in all projects. And this is how the OSH would look like with comments and operators and schemas. So this is not very clear, but we'll see later in later slides all the details that we're discussing here. Now we said earlier that all the dataset stages are converted into OSH operators. So what we call in our Datastage Designer GUI as stages are operators in OSH. So there's a particular mapping for this conversion to happen. So when you're using a sequential file stage, if you're using it as a source, then the operator is import operator. If you're using the sequential file stage as a target in your data stage job, then the operator that is inserted while creating the OSH is your export operator. A dataset stage gets converted into a copy operator. A sort stage gets converted into a tsort operator. Aggregator into group operator. Any kind of row generator, column generator, or surrogate key generator stage. So there is a common operator called the generator stage, called the generator operator. If you're using a database stage like the Oracle stage, then the source is Aura read, sparse lookup is Aura lookup, target load is Aura write, target upsert is Aura upsert. If you're using a lookup file set, then the target is lookup, create only, and so on. So you need to remember at least a few of these, mostly your sequential file operators. So these are asked in multiple dataset certification questions. Your tsort operator, which is a very important operator even from the perspective of data stage performance tuning and job score, which we'll be covering later. Now again, this is a OSH that you'll be able to see in your job. So basically what you need to remember here is that there are some comment blocks that will introduce each operator. So whenever an operator starts, then it will be introduced by a comment block. A comment block is nothing but two double hashes. Okay, so if you are able to see here, I know the picture is not very clear, but if you're able to see over here, you'll see that there are two hashes and it's called operator, and then you have an operator name, which is generator. Generator we saw was an operator for any kind of generator stage, could be a row generator stage, a column generator stage, or a surrogate key generator stage. Now all these operators which are added to your OSH are in the order in which you add the stages while designing your data stage job. But the execution order is determined by your data flow. So your source, which one is your source, then what kind of processing is happening, then what kind of processing is happening, and so on. So the execution order would always be determined by your data flow. So if you see the syntax over here, you have something called the operator name, then you have a schema. The schema would again convert your data set or whatever schema table definition you have in your job. So it would convert into a corresponding OSH data type. And then from one stage to another. So one stage will have some kind of operator, the next stage would have another kind of operator. To create a link between these two particular stages, what we do when we design a job in data stage GUI, we use a link stage. We use a link to combine, to direct the data from one stage to another. So that link is converted in the backend as a virtual data set. So that is what you'll be able to view in your OSH as well. All the virtual data sets have the extension of .v. Okay, so you can identify them that way. Now, as far as the terminology is concerned, and as far as how the conversion happens when the OSH code is generated, a table definition, what we call a table definition in Datastage GUI, is converted to a schema, what is known as a schema. A property that you define in a Sage Editor window is known as format. Your SQL column types are converted to C++ data types. Your link becomes a virtual data set, because your link in a job is nothing but a virtual data set that carries data from the previous stage to the next stage. A row is known as a record, a column is known as a field, a stage is known as an operator. When you're using or viewing the log messages in your Datastage director, if you view them closely, you will now know that they actually use the OSH terminology to refer to the various stages. Okay, so again, we have some questions over here which are related to these OSH schemas. So let's try to answer the first question. Which two statements are true of the column data types used in the orchestrate schemas? So you have to choose two options, and you can see that there's a lot of information that the column data types are same as those in data stages. We already know that that is not true. There were char integer, the int32 and string and all those. They convert data read from sequential files into schema types and so on. So we have to choose two correct options, and the two correct options are that this is true. We just saw that the OSH import operators convert data from the sequential file into schema types. So whatever data you have table definition defined in your Datastage job, that would be converted into some schema types as per the mapping that we saw earlier. And the next correct option is actually that these are the valid schema column data types in the orchestrate. So to be able to answer this kind of questions, I have given a link below, and I'll share this with you in a mail that I send after this session. So you can access this link, and this link basically has the data types and attributes for column metadata. So OSH is nothing but metadata, and these are your OSH data types. So I'll give you that link so that you can view properly. And this is a corresponding Datastage GUI data type. So if you define any column data type as tiny int, that gets converted into int8 or uint8, basically, depending on whether you have defined Unicode or not. A small int gets converted into int16 or uint16 and so on. So you can see double gets converted to dfloat, char and varchar get converted into string and so on. So just take a look and try to remember these valid data types that are possible in OSH. And if there are any questions around that, as this is the question, so you can then choose the correct answer based on your knowledge of the OSH data types, which are the valid data types in the OSH schema. So you can expect these kind of questions. So I'll share this link and you can go through this list. Now, another kind of questions that will be asked on your OSH is when a sequential file is written using a sequential file state, the parallel engine inserts an operator to convert the data from the internal format to the external format. Which operator is inserted? So here what we need to understand is that there is a sequential file stage and it is being written to. That means the sequential file stage is being used as a target. If it is being used as a target, then we saw it earlier in a couple of slides back that the export operator has to be used. When a sequential file stage is used as a source, then you use an import operator. When you use it as a target, then you use an export operator. So that is the correct answer in this case. Okay, so we'll move on to parallel architecture and understand partitioning and collecting, which are very important from a perspective of the certification exam. They're also very important from a perspective of your daily database or data stage job design, because that is one of the important things that you need to define in your data stage job for it to correctly process the data, especially if you're using any kind of aggregation stages or join stages and so on. So we'll start with this topic, but before that, if you have any questions on whatever we have discussed so far, please feel free to type them in the chat window, or if you want me to unmute you, you can put that as well, or you can unmute yourself and you can ask any question that you might have. And you can keep on typing questions in the chat window as we go along, and once we finish a topic, I'll take a look at all the questions and try to answer them. So anytime you have a question, feel free to type it in and we can discuss it when we finish a particular topic. Okay, so I'll start with partitioning and collecting. And meanwhile, if you have any questions anywhere or any of the previous topics that you have covered, please feel free again, I'll say, to type it in the chat window and we can discuss it once I stop at a particular point. Okay, partitioning and collecting. So earlier when we started the session, we saw the parallel architecture of the data stage environment and the different kind of parallelism that data stage offers. So we saw that there are two kind of parallelism that it offers, and it is pipeline and partitioning. So pipeline is something which is native to data stage. You need not go and specify it anywhere in your data stage job design. But partitioning is something that a job developer needs to control while designing a data stage job. So let's understand the kind of partitioning and collection methods and then see which partitioning is applicable in which scenarios. So let's quickly take a look at this video to see where actually you need to go and specify the partitioning. So you just need to go to your input tab. You'll have something called a partitioning type. You can choose the kind of partitioning that you want to specify for the stage. Most of the time it is the hash partitioning for any space which needs operations on key values. So you can just choose your column and you can choose to sort your data. You'll also have options of stable and unique, which we are going to discuss again later on. So you have all these options. So basically, you just need to choose your partitioning type over here. Choose the columns on which you are partitioning, whether you're also sorting on those columns. You also have the options over here, whether you can choose ascending, descending, nulls first, and so on for the sorting. Okay. So partitioning techniques are at a broad level. You can again divide them into two categories, and one of them is keyless partitioning techniques and one is key-based partitioning techniques. The keyless partitioning techniques are when you divide the data into different partitions, but that logic is not based on the values of any key column. So no key columns are involved in this computation of which record should go to which partition. The key-based partitioning techniques use the values of the key columns to decide which record should go to which partition. So let's take a closer look and try to understand how this works. Round robin and random. Now these are two keyless partitioning techniques. What they do is basically distribute the data and mostly equally across the different partitions. Round robin is simply your first record goes to the first partition, second record goes to the second partition, third record goes to the third partition, and so on. So the cycle repeats. So an analogy can be that it is something like when you are dealing the cards. So you give the first card to the first person, then to the next person, and so on. So this is your round robin partitioning because it simply distributes data record by record to each partition in that order. It mostly results in an equal distribution of data across the partition. And as we saw earlier, if there's an equal distribution of data across the partitions, the job has an optimum performance because all the nodes or all the partitions then can operate at the same level of efficiency. So we can see that there is no overhead because the computation is very simple. Random has a slightly higher overhead. So random basically does not follow this order of round robin. It randomly distributes data across the different partitions. So the first record can go to the first partition or the third partition. Then it decides that the second record should go to the second partition, also on to the fourth partition. So it also results in equal distribution of data because it distributes to each partition, but it does not follow an order of distributing to the first partition, then the second partition, and so on. So that's why it's a slightly expensive partitioning method, because there's an internal calculation on this random number or the random partition number to which the record should go, though it also results in equal distribution of data. So from the perspective of improvement of the job performance, it is a good technique to be used, but round robin is the one that is the best and the easiest to use and the most efficient. Now, when you're designing your Datastage jobs, you do not most of the times go and explicitly define the round robin and random partitioning techniques. Random, to be honest, is very rarely used because there's not much practical or business use of it. So if you want to specifically specify a partitioning technique to equally distribute your data, so you want to make sure because you have some performance impact happening, then you would anytime go and specify round robin. Most of the time you'll see that there's stages which do not need a particular kind of partitioning. So you're just passing your data. You have a source stage, you have a copy stage, and then you have a target source, a target database stage. So you're just passing your data from one stage to another. You're not performing any calculations. So you actually need any kind of key-based partitioning technique. So in that case, the most or the best partitioning technique to use is round robin. You will see that most of the time it is left to auto partitioning. Auto partitioning is picks up round robin by default for these kind of stages where no explicit partitioning is needed. The next kind of partitioning that we're going to discuss is entire partitioning. Entire partitioning is also a keyless partitioning technique because the entire partitioning basically distributes all your data. So this is all your data and it distributes it across all the partitions. So if you have 10 records in your data, reference data, and you have 4 partitions, the 10 records, node 1 will also have those 10 records, node 2 will also have those 10 records, and so on. So each of the partition will have those 10 records. So obviously this has a performance hit because we are duplicating data across the partitions. Then what is the use of the entire partitioning? Entire partitioning is useful for lookup reference links, and it is useful when your reference data is small enough to fit in your RAM. Why it is advantageous to use in a lookup reference link? Because the lookup operation becomes very fast. The data is available in all the partitions. The same data is available in all the partitions. So whenever you have an incoming source record, you can hit any partition and you'll find a match there. So you do not need to go from partition to partitioning to find a match for your input data record. So that is why it is very fast in case of lookups and it makes the operation very efficient. But the thing that you need to remember is that it is by default used for lookup reference links, but the catch or the constraint here is that the reference data should be small enough to fit in your RAM. If it is not small enough to fit into your RAM, again, it has performance hit. Next, we move on to the most important partitioning technique, and which is the hash partitioning technique. This is a key-based partitioning technique, and it is to be used in almost all the key-based operations that we're doing on the Datastage Designer window. So if you're using a sort stage, you have to use hash partitioning. If you're using an aggregate stage, you have to use a hash partitioning. Many times in transformer stage, you are doing derivations using stage variables to perform different calculations. You have to use hash partitioning, remove duplicates, funnel, all those areas you need to use hash partitioning. Hash partitioning basically works on the values of the key columns. So you define the hash partitioning to operate on a key column. So let's say customer ID is customer country is your key column. So that is your key column. You want to group the data by the country of the customer. So it is equivalent to the group by operation in the SQL database operations. So if you look at the example here, you'll see that there's this data 0 and 3. So we have partition by this key column, which has this data distribution. So you can see in partition 1, all the records which have values of either 0 for the key column or 3 for the key column are there in the partition 1. The values of 1 for key column, all those records are in partition 2. All the records with value 2 for the key column are in partition 3. So based on the distribution of your key, of the data for your key column, the data would be distributed across the partition. So this may or may not result in equal distribution of data across the partitions, because it all depends on the distribution of data of your key column. So again, as I said, it's very important for the join stages, merge stages, remove duplicates, even for lookups, aggregations, because whatever kind of operation you're performing, you have to make sure that the data resides, similar data resides in the same partition. So when you're performing a join operation, we have to hash partition the data by the same key column for both the links, the left link and the right link, because we want the data, let's say we want the data with the value of 1 to be in the same partition from both the links so that the match can be found. Let's say this data is in some other partition, so data 1 is in this partition, one record with key value of 1 is in another partition, and so on. So when you're performing the join, it will not be going from one partition to another. It will try to look for all the records in this particular partition. It will not find the 3 records in this partition. It finds only 2 matches in this partition, and your results would be wrong for the join operation. So that is why you have to make sure that you use the correct hash partitioning on the correct key column when you're performing a join operation. Similarly with remove duplicates, you have to make sure that your data is grouped by this key column. Let's say there were only 2 records in this partition. One of the record was in partition 1. Now, when you're trying to remove duplicates, one record will be removed from here, but the other record that lies here in partition 1 will be untouched because it is not a duplicate as per the data in partition 1. So your results again would be incorrect in that case. So it is very important to define hash partitioning for all these kind of operations. Otherwise, your data results would be incorrect. Another partitioning method is the modulus partitioning method. It is somewhat similar to hash partitioning method, and it has a particular formula that defines which partition your input record should go to. Now this is also based on the key values. So it is based on the values of your key column, but it follows this particular computation. So it does a mod of key value divided by the number of partitions, and then it defines which partition your data should go to. It also results in equally sized data or not, depending on your distribution, your data distribution in your key column. This is actually, it appears that it it is doing a particular computation, so it might be an expensive method than hash partitioning, but it is actually a simpler computation than what happens in the hash partition for some reason, and therefore it's a faster method than hash partition. But still, speaking practically, I've never seen modulus partitioning being used anywhere in Datastage job, and I would suggest you to go with hash partitioning for all the stages that we have mentioned earlier. So go with hash partitioning. The performance hit is not that high, and this is a partitioning method that is used as a standard in all the Datastage jobs for all these stages. Now, another partitioning method that might be useful to you as per your job requirements or business requirements is a range partitioning method. Range partitioning method basically distributes a range of data into a particular partition. So you have the distribution of data in your key column, and as you can see, you have the data from range 0 to 1 in partition 1. Then you have data from range 3 to 4 in partition 2, and your data for range 5 to 6 in partition 3, and so on. So this is mostly one example that we can think about is when you have data related to age and you want to constrain data, like let's say we want data from 30 to 40 years to be in a particular partition, or we want to group it together, and 40 to 50 years we want to group it together. So partitioning, a key-based partitioning method is nothing but grouping the data. It's basically grouping the data, and then you perform an operation on that group of data. But when you apply a range partitioning method, it is a two-step process. So there's something called a range map that needs to be generated, that needs to read all the data to generate the range map, and then it would partition the data across the different partitions. So it has limited use, as we can understand. It's only useful in cases when incoming data distribution is consistent over time, and we want to be sure that it is consistent, because otherwise it would result in fairly unequal distribution of data across partitions, which might impact the job performance. So again, I have rarely seen the use of range partitioning. It's rarely used. So as far as the certification exam is concerned, you should be aware about the concept of range partitioning. And so you should be aware about all the partitioning methods, which includes range partitioning. So you should at least be theoretically aware about the range partitioning. Now, going back to one of the keyless partitioning techniques, it is the same partitioning algorithm. Same partitioning algorithm is the fastest partitioning method. There's no overhead because nothing is being done. Same partitioning method simply means that you do not want to partition the data in any format. Just retain the partitioning method. Whatever partitioning has already been applied to data, just retain that as it is. So if you have a data set with partitioned data, and then you have a next stage in your job, let's say the sort stage, and you just need that data sorted in the same fashion as it was already sorted in the data stage when it was loaded, then you can specify same partitioning. It would greatly improve the job performance, because now data stage does not have to do anything in the back end. There's no extra operation being performed, and data simply moves smoothly from the dataset stage to the sort stage. So it retains the current distribution of data from the previous parallel stage, and it is very useful in improving the performance of the job. So if you are especially working towards performance tuning of the job, or if you're designing a data stage job in the first place, and it's a big job and you know that it would need to handle a large volume of data, so you want it to be scalable as far as the job performance and data volumes are concerned, then it is a good practice to go and explicitly define same partitioning. Now you would see that when you design a data stage job, it automatically inserts the auto partitioning. So it does not mandate it for you to go and define a particular kind of partitioning method. So you can use a join stage and not define any kind of partitioning. But what we need to understand over here is that data stage does its best to insert the right kind of partitioning. So if you're just reading data or passing it between stages, it would try to use round robin or same. It would also wisely try to use hash partitioning for stages that require key column operations like the join stage or the remove duplicate stage. It will also by default use entire on any lookup reference links. But at the same time, we need to be aware that data stage does not know what kind of design we are making for a job, what is the data flow that is going to happen in our job, what is the requirement that we're trying to fulfill, and what are the volumes of data that we're trying to handle. So we should not be relying too much on the auto partitioning method that data stage substitutes on its own, and we should, as much as possible, try to explicitly define the partitioning method. Only in scenarios like you're reading from a sequential file, just read it as auto partitioning. You are just passing using a copy stage, you can leave it as auto partitioning. So where you do not need to actually go and define it explicitly, because these are low cost operations, so we can leave it as it is. But otherwise, it's always a good practice to explicitly define your partitioning technique based on your understanding of the data, your understanding of the job logic, and your understanding of the requirements. Now there's something called a preserve partitioning flag. So preserve partitioning flag has three values. So you can either choose set, clear, or propagate. If you choose the set value for the preserve partitioning flag, It is basically asking or requesting the next stage to preserve the partitioning that it has implemented for the current stage. So you have a sort stage and you have a next stage as the aggregator stage. You have partitioned your data in some way and sorted your data in some way in the sort stage. And you are now setting the preserve partitioning flag on the sort stage. So what we're saying here is that we're requesting the aggregator stage to retain the partitioning and sorting that we have implemented in the sort stage. If I set it to clear, then that means that I do not care what kind of partitioning aggregator does. So I am not concerned with that. So in that case, I do not care. I can set it to clear. Propagate, if I set it to propagate, let's say before the sort stage, there was a remove duplicate stage and it has some partitioning implemented. So what we're saying here is that the aggregator stage retain the partitioning from uh, retain whatever was the option set in the remove duplicate stage. So if the remove duplicate stage has the option of set for preserve partitioning, that means we are asking that the aggregator retain the partitioning of the remove duplicate stage. If the remove duplicate stage has the option clear set, that means we do not care about the partitioning specified in aggregator. And if the remove duplicate stage has the preserve partitioning flag set as propagate, that means we are asking it to propagate again the partitioning set from the previous stage to the remove duplicate stage. Now, a preserve partitioning flag, mostly if you see clear and propagate, clear basically is that you do not care, and that means nothing will be happening at the back end. If you set it to set, then it is simply a request, and the aggregator stage in our example might choose to ignore that stage. So Datastage might decide that no, aggregator needs to repartition the data. I do not want to retain the partitioning of the sort stage, and it goes ahead and repartitions the data at the back end. So that can happen, and if that happens, there would be a warning in your Datastage director log. So it is useful in some of the situations, but as you can say, as you can see, it does not force any stage to retain the partitioning. So in most of the cases, you can just set it to clear so that there are no warnings in your data stage director log. It is something like the same partitioning. So a better method, if you actually want a stage to retain the same partitioning, would be to go and explicitly define the partitioning method as the same partitioning method. So the only advantage you can think of the preserve partitioning flag is basically that it gives Datastage the option to override the flag value and optimize the performance of the Datastage job. So if there is any particular use case around that scenario, then you can use a preserve partitioning flag. Otherwise, in most of the scenarios, it is better to use the same partitioning explicitly if you want to retain the partitioning of the previous stage, or just set it to clear so that there are no warnings in your Datastage job log. Now, partitioning is something that grants parallelism to Datastage. But what if you have a sequential stage at the end, and now whatever data you had partitioned in the data stage job, you want to collect it in the end in some particular order. So you want to collect your data in the sequential file stage, but you want to retain some order in that data. So for that, again, there are some techniques that you can use, and those are known as collectors or collecting techniques. So you have auto. Auto is simply what Datastage does on its own. It picks up any record that shows up and outputs it to the sequential file stage. Round robin is similar to what we had in the round robin partitioning. So it picks up the first record from the first partition, then the second record from the second partition, and so on. Now, ordered and sort merge are some of the important ones. If we are particularly concerned about retaining some kind of order in the output sequential data set or file that we want to generate. So ordered reads all rows from the first partition, then second partition, and so on. So if your first partition has 2 records with the value of 1, it will read 1. If your second partition has 2 records with the value of 3 and 5, it will read 3 and 5, and so on. So this is your ordered partitioning, ordered collector method. But the most important most useful is the sort merge. So it's similar to hash partitioning. It sorts the data based on the key column values. So in sort merge, you would define a key column, let's say customer country, and you would sort the data based on the values of that particular key column. So you can see you have data partition 0 and partition 1, and then you define sort merge as your collection mechanism. So from those two partitions, it gets collected into a single partition or a single node, and data is sorted on the key column values. You can see 5, 3, 2, 1, and 0. So it's sorted in an ascending order. So you get the globally sorted result. So this is how a sort merge would work. Now, there are plenty of questions in the Dataset certification exam around the partitioning method, and I think they are the easiest one. If you correctly understand the use of each partitioning, you should be able to answer them. They're also framed into kind of scenario kind of questions. So they're big questions. You need some time to read them clearly. So read the question clearly and identify the main point in the question that they are trying to check, and then you can choose your correct answer. So let's try with the first question. You're reading customer data using a sequential file stage and transforming it using the transformer stage. The transformer is used to cleanse the data by trimming spaces from character fields. So we have a sequential file stage as a source, then we have a transformer stage. Transformer stage is doing nothing but trimming spaces from the string columns in the sequential file stage or the source stage. The cleansed data is to be returned to a target DB2 table. So now you have a target table, which is a DB2. Which partitioning method would yield optimal performance without affecting the business requirements? So let's just visualize the job design here, what they have mentioned. So we have a source sequential file stage, then a transformer, then a target DB2 stage. We read the data from the source stage. In the transformer, we trim the data for the string columns and then put it out to the target DB2 stage. So do we need to partition the data? Do we need are we doing any key based operation here? No, we are not doing any key-based operation here. So you can just check out the key-based partitioning methods altogether. So if you think about the keyless partitioning method, so the only concern that we have here to yield optimal performance is to increase the performance of the job, we need to equally distribute the data across the partitions. That is the only thing that we can try to achieve here, because we are not doing any key-based operation over here. So we already know that the best method to increase the performance of the job by equally distributing data across the partitions is the round robin method. So that is the one, that is the correct answer. So this is a way how you have to identify the important things that they are asking in the question and then come to your result. So if you see, it's a very simple question that they have asked. Round robin is the simplest method. You just need to understand what kind of requirement they're putting out in the question. Now your job reads from a sequential file stage running sequentially. The Datastage server is running on a single SMP system, and the column contains a product ID. In a lookup stage following the sequential file stage, you decide to look up the product description from the reference table, which two partition settings would correctly find the matching product descriptions. So again, now visualize what kind of Datastage job design is this. You have a sequential file stage, okay, and then you have a lookup stage. So you're looking up the data, you have something called the product IDs in your source data, and you want to look up the product descriptions. It is running on a single SMP system. That is an additional point of information that they have provided. SMP system, what do the SMP system means? What are the characteristics of the SMP system? They have shared memory. So they are using the same memory for all the nodes. They have shared memory across all the nodes. So we already know that whenever lookup comes in, one thing that we have to know is that we can use entire partitioning. Now they have asked us to use two options. So the first one would be anything with entire partitioning on the reference link. So we need entire partitioning on the reference link. So we can see that in option C, we have entire on the reference table and round robin on the sequential file. So this seems to be right. But they've asked us to choose two options. So what could be the other technique that could correctly you fetch the product, the matching product descriptions, as well as let the job be an optimum performance job. So we know that in this case, hash algorithm might help hashing on the source side, on the product ID field, and hashing also on the link coming from the reference table. So lookup, whenever using a lookup stage, entire is the best to use if the reference data can fit in memory. That is, should be your first option. But if you have to choose another option, what might also result in a good performance and correct output descriptions would be the hash partitioning. So let's go and see what are the correct options. So we have one hash algorithm. So always remember that hashing on both the sides is also one correct algorithm that you can use for the lookup. So you have two options to be used for the lookup. You can use entire on the reference and round robin on the sequential source stage, or you can use hash on both sides. In that case, it is going to perform similarly to a join operation. So it is going to give a good result, but the entire would still work the best because they've specified that it's a single SMP system, so you have a shared memory over here. So job components is also one of the sections that is specified for your dataset certification exam. And job components basically mean that you know how to use a different stages well. So sort is one of the job stages. And it's a very important operation, specifically when we look at it in terms of improving the job performance, because your data needs to be sorted for various operations to output the correct results. If you're doing any kind of join operation and so you're performing any kind of hash partitioning, it's important to sort the data as well correctly. A join operation, a join stage requires the data to be sorted and partitioned to give out the correct results, as well as only in that case would it improve the performance of your job. So sorting is very important as far as the performance of the job is concerned, and in advanced debugging of the jobs or performance tuning of the jobs, sorting is something that is looked at very closely, and people try to set different features or different settings of the sort operator in the backend to improve the performance of the job. Now, there are two options in a sort stage. As you can see, you have a sort stage and in which you have explicit options and various kind of options that you can use. You also have the sort option in your other stages as well. So if you go to the stage editor window of the other stages, you have the option to perform the sort. But the sort stage gives you more options than an in-stage sort. So let's quickly take a look over here. So if you go to the sort stage, you can define your sorting keys. Now your sorting key mode could be sort, so it will simply sort. It could be don't sort, previously grouped, and you can see what is the description over here. And it could also be don't sort, previously sorted. So these are the various options that you have in your sort key mode. And these are very important as far as improving the performance of the job is concerned. We'll look at the details a little later. Now you have the allow duplicates options. You can set it to false if you do not want, so it will work in the same way as remove duplicates. You have the sort utility option, which can be Datastage or Unix. Datastage is always preferred. If you set it to Unix, all the other options would be disabled because then sorting would be done by Unix. So Datastage is faster and native, and that's why sort utility of Datastage is preferred. You have an option of stable sort, which is set to true by default. So stable sort, you'll see that it is also an option in stage sort. So let's see that first and then discuss all these options in detail. So if it is an in stage sort, so let's take an example of the remove duplicate stage over here. If you just click on that stage and go to your input in your partitioning, when you specify a key-based partitioning technique, let's say the hash partitioning, select your column on which you want to partition the data. Then you can see that at the top over here, you have a performance sort option. And when you have that option, then you get two additional options, stable and unique, but they're not selected by default. So they are disabled by default, but you have an option to select them. Now, when we have seen all these options, we know that a sort stage offers more options than an in-stage sort. But now let's go and try to understand the meaning of all these terms that we have just seen. So first is stable sort. Stable sort basically means that you want to preserve the order of the non-key columns within each sort group. So if you have, let's say, customer ID and customer name, now you have sorted by customer ID, you had some order, whatever is the order, already existing order of the customer name within that customer ID. So let's say there are 3 records with customer ID 1 and the customer names are like A, B, C. Okay, so not a very practical example, but let's take it for this purpose. You have A, B, C. So now what you're saying here is that you have sorted by the customer ID, which is 1, but at the same time, you also want to preserve the order of customer name, which is a non-key column. So preserving this order obviously is going to make the whole processing and operation a lot slower. So use it only when it is needed. It would be needed in very specific requirements, and you have to test it a lot of times to see how it is impacting the performance of your Datastage job. Another thing that you can note here is that the stable sort by default is true in a sort stage, but by default it is not selected or checked in an in-stage sort. Now we just saw that there were different options for the sort key mode. Now this is very important as far as improving the performance of the Datastage job is confirmed. So sort key mode has 2 options, which is don't sort previously grouped and don't sort previously sorted. So it basically says that on these key columns, let's say customer ID, if you say don't sort previously grouped, you're saying that the customer ID column is already grouped and I do not want to sort on this column again. But let's say you're sorting on 2 columns, customer ID and customer key. So what the sort stage would do now is it would not resort on customer ID, it would only try to sort on customer name. So that saves you some time because it has skipped the sorting of the customer ID column. You can also say that don't sort previously sorted, which basically means that your customer ID column is already grouped as well as sorted. Now, when you are specifying these options, one thing that you need to remember here is that you need to use the same partitioning method, because you are basically saying that the previous stage is already sorted or grouped on this key column. I want to retain the same partitioning, but I want to add some more columns to the sorting. So you have to use the same partitioning method and then in the sort stage specify the additional columns on which you want to sort. So what is the difference? You can see in this figure, what is the difference? It is this particular figure on the right hand side is grouped by column 1. So you have some values 2, 3, 1. It is grouped by 2, 3 and 1, but this particular whole data set is not in a sorted order. But if you say it is previously sorted, that means it is grouped by these key values. So 1, 2 and 3. It is also sorted by these key values. So this is the difference between don't sort previously grouped and don't sort previously sorted. Now, another important part of the Dataset certification exam, it gives you a lot of environment variables which you can use to change the characteristics or behavior of the different stages that we use in a Datastage designer window. As I said, sort is a very important stage that impacts the performance of the Datastage job. Now, we saw earlier when we saw how the OSH is generated, that sort gets converted to the tsort operator at the back end. So there are various environment variables that you need to remember. There are 2: apt sort insertion check only and apt no sort insertion. If you set apt sort insertion check only, that means it will verify that the data has been sorted. If it finds that the data has not been sorted, then the job would be aborted. To improve the performance of the job, and you think that the sorting operation is not that important to the performance and the output of the data output of the job, then you can set the environment variable apt no sort insertion, and it would remove all these sorts which are inserted in your Datastage job score or OSH when it is generated. So Datastage also tries to insert a lot of T-sort operators on its own while inventing the OSH or the job score. Job score is something that we'll see, which is needed for the execution of the Datastage job. And because of these multiple T-sort operators which are inserted, it slows down the performance of the Datastage job. That is where these environment variables come in handy. So you can set the value of apt no sort insertion. That means you do not want Datastage to go and insert additional T-sort operators at the backend. You only want it to have the sort operators that you have defined explicitly on your Datastage job designer window. Now sort resource usage. Sort uses 20 MB per partition as an internal memory buffer. So you have an option of restrict memory usage as one of the options in the sort stage. You can change this memory usage. You can increase it to improve the performance. You should never try to decrease it. Okay, so if it is a particular if you think that it's a bottleneck in your job or particular sort of stage and you're trying to figure out ways around improving the performance around that sort of stage, then you can try and like play around with the restrict memory usage option and see what works best. By default it is going to use 20 MB per partition, but this is something very advanced. You should know that you can change the setting from a certification point of view, but as a Datastage developer, you should always be talking with your Datastage admins and other resource people to understand what would be the correct usage of or value for this particular option. Now you can also have an environment variable that you can use, and you can set uh, or change the memory that is to be used by all the tsort operators. So you can set this environment variable apt tsort stress block size, and you can specify the amount of memory that needs to be used by the tsort operator. So this would be valid for all the tsort operators. The restrict memory usage option is on a stage by stage basis. So you add a sort stage to a job, and within that job, you can specify this option for that particular stage. If you want to do it globally for all the T-sort operators, you can change the value in this particular environment variable. Now we saw that there are various scratch disk and resources pools that we specified in the configuration file. And we also saw that there was one specified with the keyword sort. So we had an option to do that as well. So there's a particular order in which the sort stage would use this memory buffer or the temporary disk spaces that are allocated in the configuration file. So when the memory buffer is filled, so this is your memory that is allocated to the sort stage, 20 MB per partition or whatever you set in the restrict memory usage. When that whole space is filled, then it can use a temporary disk space, and it uses it in the following order. Whatever you have defined and the named disk pool of sort in the configuration file, it would use that scratch disk. So memory buffer, then the scratch disk by the name of sort, then the scratch disk, which is in the default disk pool in the configuration file. If that is also full, then it goes to the default directory specified by the $temp directory when you install your Datastage, and then it goes to the Unix temp directory. So this is the order, and this is also important in terms of certification questions. So there might be questions around this, so you should remember this order as well as the restrict memory usage, the 20 MB per partition thing, and the environment variable. So these are important from a certification point of view. So again and again, we have been mentioning that sort stage is one of the most important stages when you are performing a job tuning or trying to improve the performance of the job. Why it is important to minimize the number of sorts within a job flow? Because every time you do a sort, Datastage has to read the whole data and then do an ordering of the data. So when there's a requirement for Datastage to read all of that data at a particular instance, then the pipeline parallelism that we talked about, that gets impacted, because now we are holding up all the records in the sort memory. We are not outputting any records to the next stage. So the next stage is just waiting. The processors for the next stage are idle. So there's a wastage of time. It impacts the job performance. So it is always a kind of break if you put a sort operation in your job. So you need to put it only when it is needed for joins, any kind of hash partitioning, it is very important to do it. Only then the operation is faster. So we have to put it there, but unnecessary sorts should be avoided. That's where the option of sort key mode of don't sort previously grouped and don't sort previously sorted are very helpful as well. So you can follow some tips, minimize the number of sorts, specify only necessary key columns on which you perform the sort. Avoid stable sorts because there is no real need to retain the partitioning of the non-key columns. Reuse previously sorted keys by using the sort key usage option of don't sort previously grouped or don't sort previously sorted. And within sort stage, if nothing else works, then you can try adjusting the restrict memory usage option to see if more memory would help your sort operation. Now let's just quickly go through some of the related questions that might be asked in the certification on this topic, and then we'll stop for the day. So as I mentioned, that is an important point, that how much internal memory a sort stage can use. So that is one of the questions that might be asked, and as we just saw, the answer would be 20 MB. So by default, how much internal memory does a sort use per partition? It is 20 MB. Now, this is kind of a scenario question, so we need some time to read this question. A job requires that data be grouped by primary keys and then sorted within each key by secondary keys to reproduce the results of a group by and order by clause in the relation databases. The designer has chosen to implement this requirement within sort stages, in which the first sort stage sorts the records by the primary keys. Which set of properties must be specified in the secondary sort stage? So your requirement here is that data be grouped by the primary keys and then sorted within each group by the secondary keys. So on the primary keys, you just want the data to be grouped. You do not need it to be sorted. You need it to be sorted by the secondary keys. You have two sort stages in your job. The first sort stage does the sorting on the primary keys. And now you have to specify what should be done in the second sort stage. So second sort stage is going to sort by the secondary keys. That is one option. But what to do with the primary keys? The primary keys have already been sorted in sort 1 stage. So we have to specify don't sort previously sorted or don't sort previously grouped. Which one you think would be the best in this case? We would be going ahead and using don't sort previously grouped. So answer C is the right one on this in this case. And why is this the right one? We could have used don't sort previously sorted because the requirement is simply in the first line specified clearly that our job requires that data be grouped by primary keys. So we just need the primary keys to be grouped. We do not need them to be sorted. So we do not need to add an additional overhead of retaining the sorting. We just need it to be grouped. So don't sort previously grouped. Specify both set of keys with a sort key option of don't sort previously grouped on the primary keys and sort on the secondary keys. So we are going to start with a topic from Monitor and Troubleshoot section of the certification today, and the topic is job score. So what is a job score? So we saw yesterday that an OSH is generated when we write a Datastage code in the Datastage designer, and we have already defined a configuration file which helps the Datastage to interpret how to run, how much parallelism to give to the job, and how to actually organize the resources to execute the job. So job score is nothing but the time taken for the job startup process as well. Job score is again nothing, it's a combination of the OSH and the configuration file, whatever are the parameters defined and whatever is the data stage code defined, it takes them together and compiles something called a score, and that is what is used for the execution of the data stage job in the backend. That is how the data stage job is executed. It is something similar to a query optimization plan in SQL. So Datastage identifies the best way to execute the job using the job score. So the thing that it identifies using the configuration file is the degree of parallelism, which node is to be used for processing which stage or which operator. If Datastage needs to insert any additional sorts or partitioners, what would be the data flow, so how many virtual data sets it needs to insert into the data stage job design, what kind of buffer operators are needed to prevent deadlocks, and how much memory should be allocated to those buffer operators. And it finally decides the actual number of processes that are running at the backend when the Datastage job is getting executed. Now, you can see this job score, and you have to enable an environment variable called the APT startup status, and it will show you the each step of the job score, how the job score is being calculated while the execution of the job is taking place, and that you can see in the Datastage director log for that job. And if you want to see the particular process IDs that are assigned to all those processes being generated, you can also set another environment variable apt-pm show PIDs, and it will show you the process IDs in the log messages. So this is important when you are debugging a job, again from a performance perspective. So you're trying to performance tune a job, then you want to see the job score, how the parallelism is being imparted, what nodes are being used, how many sorts and buffer operators are being used. If you want to assess those conditions and then assess the resources on which you are running your Datastage job, based on that, you can make a decision to change your configuration file from 2 node to 4 nodes if needed, depending on the volume of data. So that is where this job startup or job score is important. Now, when you try to execute a Datastage job, there is some time that is needed for the startup process. What is happening in that startup process? The job score is being generated in that startup process, and the job score then generates the actual processes that are running at the backend. Now, what do we mean by processes? We'll see just in a while. So that is, for now, you have to understand that is a startup overhead of a parallel job. Now we are only talking about parallel job here because parallelism, configuration files, they're all relevant only to parallel job. Now we know that job processing would end in either of these three scenarios: when the last row of data has been processed by the final operator, whenever there is an error or fatal error that occurs in the job Datastage job execution, or when you manually go and abort the job. So you have the stop option in the Datastage director or even the Datastage designer while you're running the job, and you can just press that button and stop the job. Now this is basically how it looks like. And to make it appear in your director log, you have to set this environment variable apt dump score as we previously discussed. And these are the kind of messages that you would get. It would not mention the word score anywhere. So you have to identify by these words or these sentences that you'll get in the director log. So something like this step has 13 data sets. So it has generated 13 virtual data sets or proper data sets, persistent data sets. And this is how the score actually looks like. Now, if you look a little more closely at the job score, you'll see that it is divided into two sections. The first one is your data sets, which define your partitioning and collecting algorithms. So if you look at the right hand side on this figure, you'll see this says this step has two data sets, and it defines DS0 and DS1, and then it defines which stage is being used in the data stage job. So it's a row generator, then there is a peak, then there's a second peak, and so on. And the second part defines the operator. So you can see this is one operator, and it is running on node 1. Then this is another operator. So this is the second operator that was generated, and it is running on 4 nodes. So node 1, 2, 3, and 4. And similarly, the third operator that was generated is also running on 4 nodes. So you can see that there are total 9 processes that are running on 4 nodes, because 4 processes for operator 2, each running on 1 node, 4 processes for operator 1, each running on each of these 4 nodes. So 4 plus 4, 8. And operator, the first operator is running on the first node. So one more process. So 8 plus 1, 9. So there are total 9 processes which are running on 4 nodes in this job. So this basically identifies whether it's sequential or parallel processing. So this is parallel processing because it's running on multiple nodes. So this is parallel processing that we can interpret by looking at this job score. And it gives us the information of the number of player processes that are happening. Again, this is relevant to the certification because they'll give you something like this. They'll give you a snapshot of the job score, and then they might ask you that on how many nodes is operator 1 running. So you have to come and look here and see how many nodes are defined here. Now, operators and datasets, you'll see that the counter starts from 0 in most of the cases. So if they ask you how many operators in total are being used by this job score, then just don't look at this number 2. You have to count 3 operators, because even the node numbers by default they start from 0 and not 1. So these are the kind of questions you'll get on the job score. You have a compiled job and parallel configuration file, which methods can be used to determine the number of nodes actually to run the job in parallel. So you have to choose 3 options here. So this is basically asking you where can you find this information, that how many nodes are actually being used. So we know that we can find this information in the configuration file. So whatever is the log entry for the configuration file, we'll know that how many nodes are being used. We can find it in the job score, and we can also find it in the Datastage job monitor. So if you go to the Datastage director log and right click on the job that has been executed, a monitor window will come up that will show you how many instances each stage has run from. So that would decide the number of nodes that were used to run that job. So these are the 3 correct answers you will get for this. So these are the kind of questions you will get in your certification exam. Now, which environment variable, when set to true, causes a report to be produced, which shows the operators, processes, and data sets in the job? So we have just seen that the environment variable that we need to set to see the job score is apt dump score, and the job score is the one that will produce a report and show you the operators, processes, and data sets, all those details. So this variable, environment variable, needs to be set to true. Now here you can take a look at another job score. So it is something like this. And this is what you will get to see in your Datastage director log. In the Datastage director log, there would be an entry for the job score if you set the environment variable apt job score to true. So this simply says this step has one data set, ds0, and there's some generator stage that is being used. It is using hash partitioning on some key value A. That is what the job score is saying. So it is defining that this is the stage being used. A data set, what it is referring to here, are virtual data sets. So as we saw yesterday, the links on your data stage designer window are what get converted into virtual data sets, because data is flowing from the previous stage to the next stage, or between the 2 stages which you have connected through the link. So there's a virtual data set that is taking place in the datastage server to store that data and to move that data from one stage to another. So these are the data sets being referred to over here, and it would also refer to any persistent data sets that you have in your job design. Then it is using some collection method, collect any, and it is inserting these operators from the OSH. So tsort, it is inserting. So it has 2 operators now, sequential generator operator 0, it is running on 1 node, and operator 1, which is running on 2 nodes, as we can see. And therefore, it has 3 processes running on 2 nodes. Now, if you see that there is only one operator defined here for these 2 OSH operators, tsort and p, and it says combined operator controller over here, which means that Datastage has internally combined these operators to optimize the execution of the Datastage job. So operators can be combined in Datastage if Datastage finds things that it might be useful to optimize the performance while we execute the Datastage job. Now, all throughout when we are discussing about the job score, we have been talking about processes. Now, what exactly are these processes and where are they taking place? So if you want to think about the job execution, this is what it looks like in the backend. There is your conductor node. So conductor node is a base node. It is mostly where your data stage is installed. That is your conductor node. So if you're running server jobs which do not have any parallelism, they run only on the conductor node. So it's a single node they're running on. There is no degree of parallelism and they run sequentially. So conductor node is your base node. It is what would define the initial startup process for the job. It is the one that will compose the score from the OSH and the configuration file. And it is the master node, as we can see from the figure, and then it creates some processes which are known as section leader processes, which are created one per node. It is the one that writes messages to the job log and manages the shutdown of the Datastage job. So startup and shutdown is managed by the conductor node. It creates section leader and it creates the job score and it writes messages to the job log. The section leader processes are generated one per node. The section leader processes in turn generate something which are known as player processes. This player process is generated one per operator. So whatever operators are being used or are being used in the job score, which have been derived from the OSH, one player process will be generated for each of those operators. So the player process can communicate through the to the section leader. The section leader can communicate back to the player processes and so on. So the player processes are the ones which are actually associated with the operator. Any kind of error information, any kind of informational messages, so just general information without any error or warning, they communicate it to the section leader. They can establish connections to other players as well for the data flow, and they are the ones responsible for all the cleanup of all the other processes upon completion of the Datastage job. So here what you need to understand is that the processes are generated at three levels in a Datastage job at the backend. The first one is a conductor node. The conductor node generates the section leader processes. Section leader processes are generated one per node. Section leader process generates player processes. Player processes are generated one per operator. And they are the ones which are actually carrying out your data transformation and whatever process flow you have defined in your Datastage job. And this is how they can communicate between each other. So you have conductor communicating with section leader, and these are the channels or the kind of channels which are used for this kind of communication. So you can see copy and generator, these are actually operators, and one player process is generated for each of these operators, which in turn is communicating with section leader through all these channels, and from the section leader is communicating with the conductor only through the control channel or the TCP. So this is again an example of how your job score would look like in the job, and you have all the details here. So conductor creates score. So if there's a message like this step has these many data sets, that means the job score has been created by the conductor node, as we just saw in the previous slide. Then you're defining your section leaders. So all this information is logged into your Datastage detector log, but only when you have set the environment variable apt job score to true. So all this kind of information would be available in your Datastage job. Now there might be questions in the certification exam where they would be asking you that how many total number of processes are generated, or how many player processes are generated, and so on. Based on, they would be giving you a job score and they'll be telling you how many nodes are available and so on. So how do you count the total number of processes? One for the conductor. So the conductor node generates one process. There is one section leader process that is generated. So if there are four nodes in your configuration file, then four processes would be generated because it is one per node. And player processes are generated one per operator. So if it is running sequentially, that means there is only one node available. So player process one per operator per node. Now, if you have four nodes, so you have a parallel system, the player process would be one per operator into the times of nodes you have. So let's say there are four nodes, and four processes will be generated for each operator. Each operator corresponds to one stage that you have used in your Datastage job. So if you have to calculate the total number of processes in your Datastage job, you have to look at the number of nodes that the job is using to execute, and then calculate conductor plus section leader process, one for conductor. If there are four nodes, four for section leader, and if there are four operators running on four nodes, then 4 into 4, 16. So 16 plus 4, 20 plus 1, 21. So there would be total number of 21 processes that would be generated. So in this example, we see, so it's a snapshot of a portion of the job score. How do you actually interpret all that information that is given here? So it's called a producer consumer data model, which is simple. Producer means your source stage. Your source stage in your data stage job is producing some data, and then your target stage is consuming that data, or the next stage is consuming that data. Now there are all these uh, particular string values that are here. So ENE, and if you see over here, they are greater than less than symbols together. Then it is saying E collect any, and it is defining the operators and so on. So if you go down here below, you will see that these symbols mean something. So if you are reading data sequentially, passing it to a sequential stage as a target stage, then your symbol would be something like this, an arrow symbol. If you're reading sequentially, so you're reading from a sequential file, passing it to, let's say, a copy stage, which is a parallel stage, then it is sequential to parallel, parallel to parallel, same partitioning, parallel to parallel, not same partitioning, parallel to sequential, no producer, no consumer. So these are the symbols that you can see over here, and that is what they mean. So you can just go through these symbols once if they ask you in the certification that based on the symbol what kind of partitioning or data flow is happening, then you can interpret these symbols according to this legend and you can answer the questions. So again, there's more of the snapshot from the score and you can understand it this way. So there's don't combine hash. So you can specify in your stages itself in the advanced properties, you can specify don't combine. When you say don't combine, it is basically meaning that you are not allowing data stage to combine these different operators that it is generating for each of the stage into a single operator in the jobs code, because it does it sometimes to optimize the data stage job execution performance. So you can explicitly say that this is not helping my job or the data flow is going wrong. I do not want data stage to combine any of the operators in the backend. So again, all these operators you can see, collector is ordered. So all kind of information is available in your job score and you can read that job score and help in performance during the job. So another sample question is something like which environment variable must be used to identify the host name for the engine node. So when we are saying the engine node is the conductor node, because we said that the conductor node should be where the datastage server or the engine is installed. So engine node always means the conductor node, and you should be aware that this is the variable that you can use to identify the host name for the engine node, which is the apt pm conductor host name. So all throughout whatever questions we have discussed, you would have seen that there are a lot of questions around the environment variables that appear in the certification exam. So I'll share a list of important environment variables that you can go through before you decide to appear for the certification exam, and you can go through and understand the meaning of those environment variables. What is the impact when you set them to true or false or set them to any particular value? Okay, so a job design consists of an input file set followed by a peak stage, followed by a filter stage, followed by an output file set. So you have a file set, then a peak stage, then a filter stage, and an output file set. So you have set the apt disable combination is set to true. So you can set this environment variable as well to ask data stage not to combine any of the operators in the backend, and the job executes using a configuration file with 8 nodes defined. Also assume that the data set was created with the same 8 node configuration file. Approximately how many data processing process? So this is basically data processing processes, player processes, because the player processes are the ones which would process your data while this job run on. So the important information that we need to understand from this question. First thing that stands out is that there's a configuration file with 8 nodes. Okay. Now they're asking about the data processing process. Data processing processes are the player processes. We understood from the previous slide that a player process is generated per operator per node. What is an operator? Operator is a stage that we are using in a data stage job, and we have explicitly specified that the environment variable apt disable combination. That means we have asked Datastage not to combine any operators in the backend. So for the 4 stages that we have in the Datastage job, there would be 4 operators which would be used for executing the parallel job. So we have now 4 operators. We have got 8 nodes, and we said a player process per operator per node. So simply we have to multiply operator number of operators into number of nodes, which is 4 into 8, which is 32. So these are the number of player processes that the Datastage job is generating while executing the job. So 32 is your correct answer. So this is how you need to interpret your questions. Now, another sample question is, this is simple if you remember the job execution figure from the slide earlier. So you have a figure like this, and they'll ask you to just move these boxes on to here in the correct places. So what you have to do, the first one is obviously the conductor node, then you have your section leader process, and then you have player processes. So you just need to move those to the correct boxes in the question. Okay, so now we'll move on to persistent storage. Before we move on to persistent storage, I'll again like to repeat, if you have any questions anywhere, feel free to type them in the chat window, and I'll answer them once we reach to the end of one topic. So I'll answer them, all your questions. Okay, so persistent storage, what do we mean by persistent here? Persistent is that there is a hard copy being stored somewhere. So some data is actually being stored on the hard disk. We're not talking about the temporary data being stored in some temporary drive or in the memory. So this is, or in the scratch disk. So we're talking about persistent storage. That means data being stored for use later on, and data being stored in a proper hard disk. Now, what are the stages that would help you store data persistently? Sequential files. Now, sequential files are one of the most important stages in a Datastage job, and they have a lot of features which we need to know, and especially in terms from a certification perspective. Also, while designing the jobs, they give us a lot of flexibility, and because they are a major source of data, most of the times the data is coming from upstream systems in the form of flat files or CSV files. So that is why sequential files are very important. Now, for all the stages that we use in the Datastage job on a day-to-day basis, it is good to know how many input links they can have, how many output links they can have, how many reject links they can have. So there might be questions around this aspect of the stage. So just keep in mind, whenever you're designing a job, take a note of how many input stages are possible, input links are possible, how many output links are possible, how many reject links are possible from that particular stage. So sequential file stage in particular can have a single input link, it can have a single output link, and it can have a single reject link. But you cannot have a single input link and output link at the same time in a sequential file stage. So that is also something that you need to remember. Now, if you try to read multiple files from sequential file stage, it would execute in parallel mode. But if you're reading only one file, it would execute sequentially. So it would execute only on one node. Now let's just look at this to understand how it would execute. So this is your sequential file state. If you click on it and go to your properties, you'll see that there's an option to define the file name, and then you have the read method. So you have file pattern and specific files. File pattern, if you define, that means you're defining a wildcard kind of something. So star.txt. So you can read the file names based on the file pattern. Now the first, let's wait. First line is column name. You can set it to false or true. So false basically means here, just a second. Let's go through all of them. Okay, first line is column names. So if you have a sequential file or a flat file that you're reading with the first row in that file as a column names, that would be a header record. You can specify it here, and this would skip the first record while reading the data from the file. You want to keep the file partitions. If there are any existing file partitions that are there, then you can specify it as false or true. Most of the time this stage is not used. Missing file mode would have the, you can define if you want the skip the missing files. So if you're reading using the file pattern, let's say, or specific files, and you define a list of files to be read, so you're reading multiple files and it does not find one of the files, so one of the file is missing, then you can define the action that you want to take in the missing file mode option. So depends, continue, skip. Okay, then you can define the reject mode, which can be continue. Reject mode is basically applicable when you're reading data from a sequential file. You need to define some metadata, which means you need to go to the columns tab here and define the structure of the data that you want to read. So let's say I define a column as integer, and when I'm reading the data, it is coming as some string characters. So you can define the action over here. The reject mode continue means it would simply skip that record and read the remaining data. You can also define the reject mode as a reject, in which case you can have a reject link coming out from the sequential file stage, and that record with the incorrect data would be captured in the reject link, so you can use it to analyze the data later on, and so on. Report progress is something that means you want to show the progress of how much data has been read by the sequential file. So it can be like when your data is huge, you can set this to yes, and by default also it is yes. It will only show when your data is greater than some 100 MB or something, and it will show the progress at 10% each time. So it will show you something like that when you are seeing the statistics in the job run. It will show you that 10% of the file has been read, now 20% of the file has been read, 30% of the file has been read, and so on. But the data has to be really huge for this to happen. Okay, so these are the various options that you have in this sequential file stage. Now, so this is your report progress. You can set it to yes or no. Now, if you just click on the options over here, you'll see that there are available properties to add. Okay, so you can add a file name column. So it would just add a column to your output with the name of the file that you're reading, especially useful in case you're reading multiple files, so you would know from which file you have read which data. You can have a reject reason column, so it would give you the reason why that particular record was rejected. You can have a row number column, so it would give you the row number. It would just add an unsigned begin column. So you have all that information over there if you see on the right hand side. Now this one is important, schema file. Schema file is basically used when you have an explicit schema file, so you do not need to define your column definitions, and you can use a schema file with the runtime column propagation. So we'll just see about it down below in the slides. So we'll talk about it later at that particular point of time. So let's skip that for now. Now if we change the read method to specific files, so now we have changed the read method over here. There were two read methods, remember? There was a file pattern and specific files. When you say specific files, you'll see that there's some additional options that are available to add. Filter. Filter is any Unix command you need to use, apply on your flat file. Filter the data from there. Now another one is number of readers per node, and you can see over here that you can increase the number of readers from 1 to 4 or so on. Another option is read from multiple nodes, which can be set to no, or if you decide to set it to yes, then you'll get an error message that this is mutually exclusive with the number of readers per node property. So you can set it to yes, but you will not have the number of readers per node option. In that case, that would be disabled. Now, what do these options mean? Read from multiple nodes and number of readers per node. Now, these are the ones which are very interesting, especially from a certification point of view. And let's go further down below and see. Okay, so if you have read from multiple nodes, or let's say number of readers per node. So what this does basically is that per node, we know that a sequential file operates sequentially. Okay, so there is no parallelism, but we can increase the performance of the sequential file by imparting some degree of parallelism to the sequential file job. So if we specify the number of readers per node as anything greater than 1, there would be some degree of parallelism. And how? Because what we're saying here is that on every node, we are specifying some logical readers. So these are only logical things. They are not physical capacity that is available. These are logical readers or logical points that we are saying. So each node, let's say there are 4 readers that we are specifying. So your sequential file would be split. Your data from the sequential file will be split across those 4 readers. So now, at the same time, simultaneously, those 4 readers are reading data from your sequential file from different sections of your sequential file. So that is a degree of parallelism, right? Because 4 processes, 4 read operations are happening at the same time. So that is the use of number of readers per node. So if you have a especially huge sequential file and the data is being read very slowly because it is being read sequentially, then you can explore this option of number of readers per node. Now, this is especially useful when you are running it on a symmetric multiprocessing kind of system. You can also read it from multiple nodes. You have another option over here, which is called read from multiple nodes. As we saw earlier, it is mutually exclusive from number of readers per node. So in this case, what is happening? You're simply saying that read from multiple nodes. You have 4 nodes available in your configuration file, and what you're saying is that split the data from the sequential file across the 4 different nodes and read it from those 4 different multiple nodes. So again, this would impart a degree of parallelism to your data stage, sequential file stage. So again, these are very important from the certification point of view. You will have questions around this, definitely at least one question on this topic, that how can you improve the performance of the sequential job, and they'll give you these 2 options, which options can be used to improve the performance of the sequential file job. Now, schema files, we just saw earlier that there's an option to use the schema files to read from the sequential files. Schema files have to be used when you do not want to explicitly define your column structure. So you want to read the data, but what you are getting from the source is a schema file along with the data. So this is especially useful again in cases where your schema is not consistent. So you want every day some data is coming, there is one additional column coming one day, there is one less column coming one day, or there is a different kind of file, that is input file, that is being sent to you from the upstream process for processing in your data stage job. So your column structure is not consistent. In that case, a schema file can be used. It is similar to a table definition. It is a plain textual file. Schema file is nothing but it uses your table definition format and syntax. So basically some kind of OSH syntax. It can be also imported as a table definition. It can also be created from a table definition. But when you use a schema file, what you're saying is that you want to read the metadata information from the schema file. So on the columns tab of the sequential file stage, you would not be defining any particular columns explicitly, right? So another property that you need to enable for this is the runtime column propagation. Runtime column propagation basically says that you have not defined any particular columns on your column tab of the stage, but still whatever columns the stage is reading from the source, just propagate them as it is to the next stage. That is the meaning of the runtime column propagation. So this is how a sample schema file looks like. You can see it just defines the structure. So you have a record, you have a final delimiter, you have a delimiter of comma, your record delimiter is a new line, and so on. Then it defines the columns which are needed. So name, string, your data length, and so on, whether they are nullable or not nullable, and so on. So this is how you define a schema file. And I'm moving quickly. If it is too quick for you, you can let me know. But I'm moving quickly because there are a lot of content that we need to cover. So that's why I'm just saying that any questions anyway, just type them in the chat window and I'll answer them once we reach the end of a particular topic. Okay, so moving again to the section of metadata. RCP, that is runtime column propagation, something that we just talked about while using the schema file. How does it look like? Let's see here. So this is a sequential file stage that we just saw, and there's an option of schema file, and you can just specify schema. So you have to specify your path to the schema file. So if you're running on a Unix based system or a Linux based system, your file will be residing somewhere in your Unix server or the Linux system, as are the other flat files. Okay, so you just need to define, because it's a simple text file, so you just have to define the path where the schema file is available. On the columns tab, there is no need to define any particular columns. Now, how does RCP work? When it is turned on, then columns of the data can flow through a stage without being explicitly defined on the columns tab of the stage. Output columns, input columns, you do not need to mention anything or type anything in there or load any kind of table definition. It would pick the columns as defined in the source itself. Now, one important point here, no column mapping enforcement at design time. So if you're not using RCP and you decide to not define any output columns or any input columns, or let's say you define output columns, you do not define any input columns, and you try to compile your Datastage job, you will get a compilation error. Because when it compiles the Datastage job, it checks for some mandatory things, which include a mapping enforcement. So it will check that, let's say you're using a transformer stage, you have defined some output columns, you're reading the sequential file using a schema file, so you have not defined any input column. And now you're trying to compile the job and you do not have any mapping defined in the transformer stage. So you will get a compilation error. But still, that is what we actually want to do. So we need to go and enable RCP as an option in the input tab of the transformer. And once you enable that, then no column mapping would be enforced and you'll be able to read your input columns. What are the benefits of RCP? RCP benefits, obviously, as we can understand, are your job flexibility. So you can read from different kind of input structures of your source file or any database table, so as to say, because all the stages have the option of RCP or propagating the columns as is. So the job flexibility is obviously the topmost advantage of RCP. So you can read and process data from different column layouts without explicitly specifying it in your Datastage job, and it is reusable, right? Because you can then use the same job for running or processing different kinds of data in your Datastage job flow. Now this is what we're talking about. So this is your transformer. You can see over here that you have some input links defined. Now in the output link, this is an example where we are just propagating whatever in the input link to the output link. So we're not defining any columns over here. But you'll see in the next stage, and if you want to specifically loading some data to the table or something like that, you'll see that the data would get loaded. Now, where is that option to enable the RCP? You just have to go to your stage properties. And if you go to the, okay, so there's an option on the outputs tab over here called Runtime Column Propagation. Because we are asking the output tab to propagate all the columns. So if you just check it, then the columns would be propagated as is to the output link that you attach to the transformer stage. So this option is available in all the stages. So you can just check that option if you want to use the RCP. Now this RCP can be enabled at multiple places. You can enable it at project level in the Datastage administrator. Then you can enable it at a job level. So in the job properties window as well, you have a general tab where you can enable it. You can enable it also at the stage level in the output columns tab. I'm sorry, I mentioned input earlier. So you can enable it in the output columns tab. And the thing that you need to remember is that let's say you have enabled it at the project level. So you said that RCP should be applied to all the stages by default, whatever stages we are adding to the Datastage job. Now you go to the particular job, and in the any of the stage, let's say the transformer stage that you're using in the job, you do not want RCP to be specified because you want to actually drop the columns from the input, because you do not need those columns in the output. And if you take unnecessary columns, then again it is going to impact your job performance. So you can go to the transformer stage and uncheck the option of RCP. When you do that, it would be Datastage would override the project setting. So though at the project level we said that RCP should be enabled for all the jobs, you have an option to go at a lower level and override that property. Now, one thing again to remember over here is that when it is set at project level, specifically set at project level, you should be very careful and mindful of disabling or enabling the RCP option. RCP option should only be enabled when you actually want that functionality to be there. You want the input columns to pass as it is to the output tab, all the input columns. None of the input columns will be skipped. But if by mistake you leave that option turned on, so that option is checked, you will find that extra columns have been propagated from the input to the output, which you did not want in the output. So if there's no such requirement for you to propagate all the input columns to the output link, then you have to go and uncheck it. Otherwise, it would impact the job functionality, and it might also give you errors and warnings in your Datastage director log that this column was found and you did not specify what to do this column in the next stage, or so on. So you have to be very mindful of the RCP option. And this is how it looks like when you want to enable it at project level. You just have to go to the General tab. In Datastage Administrator, you have an option to enable runtime column propagation for parallel jobs. That is one option. And then there's another default setting for new parallel job. Enable runtime column propagation for new link. So any new stage, any new link you add, the RCP would be enabled. So these are two options that you can choose. And the job properties window, you have again in the general tab, enable runtime column propagation for new links. You can check it or uncheck it. And in the stage, as we saw in the output tab, you have the runtime column propagation. Now, from a certification point of view, this particular line is very much stressed upon, which is Datastage does not enforce mapping rules when RCP is enabled. So there might be questions around this particular sentence. So keep this in mind that RCP enabled means Datastage does not enforce mapping rules. Okay. Okay, so some sample questions around this topic. Which two must be specified to manage runtime column propagation? Okay, so we just saw that runtime column propagation can be enabled in Datastage Administrator. It can also be enabled at the stage level. So a simple, straightforward question. Okay, which statement is true when runtime column propagation is enabled? So what happens, as I said, that it places special emphasis on that particular sentence. So just remember the sentence that Datastage Designer does not enforce mapping rules. Okay, so going back to the sequential file, what are the other ways in which we can improve the performance of the sequential file? So sequential file by default is actually is designed to read the data sequentially. So if the data becomes too large, sometimes we need to improve the performance of the sequential file. We saw two options earlier, which were readers per node option or read from multiple nodes. So you can set either of those based on your environment that you are using to run the Datastage job. But what are the other options that can be used to improve the performance of the sequential file? So one option is that you can define a large string column, so long varchar, okay, and read all the data of one record in a single column. So let's say you have 4 input columns, okay, customer ID, customer first name, last name, and customer address. You can read them as 4 columns, separate columns, or read everything as a long varchar column and define it as a one single column, which is like something like data. And then you can use a column import stage next to the sequential file stage and pass those into separate columns. So again, a column import stage would basically divide the column from the single stage into 4 different columns that were actually defined in your source file. So what would happen is sequential file is a sequential stage. So it runs the data process data sequentially, but the column import stage is a parallel stage. So you have just read the data in bulk using everything as one record. That would be so much faster than reading the 4 columns separately. And then you have used a parallel stage to actually split the data into 4 different columns and process it in the downstream processes. So that is one way you can improve the performance of the data stage, sequential file stage. Now, at an advanced level, you also have an option to set some environment variables. The environment variable is called APT import buffer size. So it basically defines the amount of data that sequential file will keep in memory or in buffer while it is reading the data continuously from a flat file or input source file. So you can change the values of these buffer size operators and play with it and see what gives you an optimum performance. Again, all these things have anything with environment variable, changing the value of the environment variable, especially relating to the memory size, should be done in consultation with the Datastage administrator who knows your environment better. But again, we are talking from a certification point of view, so you should be aware that these are the options available and these can be changed or played around with to improve the performance. Okay, then you have this was the APT import buffer size. Another environment variable is the APT consistent buffer IO size. So there are some systems, again, your Datastage admin would know, there are some kind of disk arrays that can have an advantage when you read the same size of file chunk data every time in those disk arrays. So you can set it to yes or no, and you can take advantage of this environment variable to improve the performance of the mm, uh, of your sequential file read operation. So just be aware about these environment variables. Another environment variable is your APT export flush count. So this is basically how frequently the sequential file stage is writing data from the buffer to the write operator. So write operator is your exporting data to the next stage. So if it is writing very frequently, that means there is a lot of communication happening between the buffer and the write operator. So obviously it is a performance penalty. It takes much more time, but then it is advantageous in case of real-time processing, because you need data to be available quickly, the current data to be available quickly to the output stage. But the data stage is mostly a batch, like data stage jobs are mostly batch jobs. So they run like once in a day or 5 times in a day. So they run at specified intervals. So do not set it to 1, but you can play around this export flush count. You can increase the value, try to increase the value and see if it results in improved performance. Now, another thing that we need to be careful while designing a data stage job, and especially with regards to some of the stages, are the handling of nulls. So nulls are very important. They can just mess up your whole result if you do not handle them correctly. So let's say you wanted a summary of data to be calculated and now you have some nulls in the value, then what would happen? Your output might come as nulls. You wanted to convert them earlier to zeros, but you're misconverting them, so some nulls happen. So nulls are something that can mess up your data. So you have to be very careful. Sequential file stage is one where you actually need to go and define how you want to handle the null, right? Because it cannot otherwise import the data from your source file. So you need, or write the data, null data, to your target file. You need to define what should be the value of that null field column if there is any null in that data column value. So if you see over here, you'll see that we are in the columns tab of the sequential file stage, and you can define the nullability. So if the column is nullable, that means the source data might contain null values. One thing that you can do is go over, like we went to the left hand side and double clicked on it, and then we have this added column metadata window pop up where you can define your null field value. So you can define your null field value. If it is a varchar, you can define it as empty strings. If it is a character, let's say 10 spaces, you can define it as 10 spaces, and so on. So you can define your null field value over here. If you do not define a null field value over here, that record will be skipped or rejected as per the setting you chose in your sequential file for the reject mode. Okay, so that is why if you want to read all the data from the sequential file stage, it is important to define the null field value. So this is one way in which you can define the null field value. Now there's another way in which you can define the null field value in the sequential file, and it is basically go through the format tab, and in the format tab you have an option over here where if you go to field defaults, you will have an option available property to add, which is null field value, and you can define the null field value over here. So this would be applicable for all the columns, and in that case we define it particularly for one particular column. So even you can like define it over here and go to the added column metadata and define for some particular character column or something over there. So this is how you have to define. You have to do it while reading the data from sequential file or while writing to the data to the sequential file. This is important and this needs to be done. Now, how do you make sure that you handle nulls correctly in the other important stage, which is your transformer stage? So transformer stage is another place where you need to handle your nulls explicitly if you want your output to have correct data. So if you go to any of the column derivations, you'll see that this column is nullable. As you can check from the nullable property, you can let's say we have in the target, this column is not nullable. So from the source, it was nullable, but from the target, it is not nullable. So now we need to handle the null which might come from the source. So you have a function, null handling functions over here, and you can choose any function to convert the null value to a valid value over here. So you can convert it as null to empty. So it would be an empty string. This is varchar. So you can convert it to an empty string. You have another function called null to 0, which you can use if you are writing data to an output decimal or integer data type. So you can use that function as well. And then you have null to value option as well. So in null to value, you can actually go and specify a value. So you wanted to convert all the nulls to, let's say, an X in the output. So you can define your values explicitly over there. And then you have these is not null and is null functions, which can be used in your if then else statement. So if it is a null value, then do this. Or if it is not null value, then do this, and so on. Okay. So the point here is that it is important to handle nulls correctly if we want the output results to be correct. Okay, so what are some of the sample questions around this particular topic? So this is a question. A bank receives daily credit score updates from a credit agency in the form of a flat width flat file. The monthly income column is an unsigned nullable integer whose width is specified as 10 and null values are represented as spaces. With sequential file property, will properly import any nulls in the monthly input file. So what is the important information that we can derive from this particular question? So the question is, there is a fixed width flat file that is going to be a source. There is a column which is a monthly income column. It's a nullable integer value whose width is specified as 10. Okay. And null values are represented as spaces. So what do we need to do? So this seems like we have a source file which has a nullable column, and the nulls in that column, we need to represent them as 10 spaces because it's a fixed width file and the width is specified as 10. So in that case, to be able to read any null values that come in, we need to specify the null field value to some default value. But what should it be? Should it be empty space, a single space, or 10 spaces? Now they have that requirement that they want the null field values to be represented as spaces of width 10. So your answer is that you have to set the null field value property to 10 spaces. So that is how you have to interpret the length that you need to set. Okay? Because their particular requirement is to set it to 10 spaces. Then you have to specify the null field value property to 10 spaces. Now these nullable columns are also very important when we're talking about the lookup stage. So lookup stage, if you run it in the mode of continue, so that behaves as a left join, we know. And what we need to remember here is that there might be some columns from the source. So we have a reference link in a lookup stage, we have a primary link in the lookup stage. The reference link columns might be defined as not nullable in your reference database or the reference file from which you are reading. But if you're running the lookup stage in the continue mode, what we're expecting is that if there's no match found for the input record in the reference link, then we should have a value of null for the reference link columns for that particular record. So a record with no match found in the reference link should have the value of the reference link columns as nullable. But the reference link columns themselves were defined as not nullable. So what should be done in this case? You should actually go and define them as nullable, because then for any mismatches, you will get reference values as nullable in the output. And then you can define your logic and you can check if the reference value columns have a null value. That means that the match was not found. Now, what happens if we do not do that? If we do not define those values as nullable, then what would happen? It would actually lookup stage would default the values. So for no matches found, you have defined a column as integer not nullable. It would default the value to 0. If it is a string column or a varchar column, it would default the value to an empty string. If it is a character column, it would define some particular number of spaces, whatever you have defined in this environment variable, ABT string pad char, which is defined to have some definite spaces concatenated to the char data types. So it would, now it has actually assign different kind of values for different data types. So if you are to write a job logic later on to find out the records that did not have a match, I mean, it would be very difficult to write it because you would have to first check for the data type. So for this column, check for value 0. For that column, check for an empty string, and so on, which might actually be valid values on those columns as well. So that is why whenever you're using a lookup stage, make sure that from the reference link, you make your columns, non-key columns, as nullable, so that for any mismatches, the value that you get in the output link is nulls for all those columns, and then you can easily put a logic on those columns to check for null values. If the value is null, then it is a mismatch. If the value is not null, then it is a match. Okay, so dataset is one of the other persistent storage stages in data stage, and uh, the difference between a dataset and a sequential file stage, we have seen multiple times, and if you have been regularly developing data stage jobs, you might be already aware that sequential file stage is stored in an external format. Dataset is in the native data stage format, so it is faster to access datasets if you are just using them as intermediate files. But if you need your files to be available to any external system or platform, then you have to use a sequential file stage because it generates files which are accessible by the external platforms. Now, a data set is an internal representation of data. The advantage of using it as an intermediate file is because it retains the partitioning and the data types which are native to datasets, and it's faster for datastage to process the data in the datasets. Datasets consist of a schema and data. So datasets are not simple flat files. They are operating system files. They have a descriptor file and they have multiple data files. Descriptor file contain information like the schema, the configuration file, the data file locations, and so on. Virtual datasets are something that are created in the datasets job when data flows from one stage to another. So any kind of link that you're using in a datasets job, that is a virtual dataset because data is flowing from the previous stage to the next stage. In terms of OSH, datasets are converted to the copy operators. As we mentioned that data sets are not simple flat files. So if you want to delete the data sets, how do you go about it? You cannot use the Unix commands rm-f to delete the data sets. You have to use some special data stage commands, which are the org-admin commands. So the org-admin is nothing but a command line utility which helps you manage the data sets, and there are various options which are available with the org-admin command. So there are various options like the org-admin check, org-admin copy, org-admin delete, which is the most important one. So you have your data directory filled up with data sets and you want to clear some space, then you have to use org-admin delete command to delete those data sets. So this is one of the most important commands. And you have a list of commands that can be used with the org-admin command line utility. So I'll provide you all the lists and you can go through that list, but the most important one is the delete option that you have in the org-admin. So there are lots of options that you can specify. So just go through all this text and all that information, what all those options mean. It's just straight read. You can just go through it. So I'll share this file with you um, in the next week, and you can just go through this various options which are available and you can use it. So org-admin delete, the most important one. There's something also known as org-admin truncate. So truncate does what? It just deletes the data from the data files. So your operating system file, your descriptor file is still there, .ds file is still there, but the data has been deleted from your data set. So if you need that option. Now, in terms of the kind of questions that are being asked in certification, which two ways you can use to delete a persistent data, parallel data set. So your two ways are the org-admin command rm. So org-admin delete, you can use in place of delete. You can also use org-admin rm. So that is an option. And then delete it in the dataset management utility. So this is not manager. You can just say management utility that allows you to delete the dataset. So dataset management utility, if you're not already aware of how you can go and use a dataset management utility, I'll provide a link to the video that is already there for dataset management utility. It's pretty straightforward. That's why I'm not covering it here. So you can go through that video and just understand how you can handle datasets through the dataset management utility. Okay, so another similar question that is asked is, a client requires that a database table be done using two jobs. The first job would create a dataset, the second job reads the dataset and loads the table. The two jobs are called in a job sequence. What are the three benefits of this approach? So again, this is a simple question to test your knowledge of the foundational knowledge of dataset, why they are important. So as we already said, they are important because in this case, in this kind of structure, what you're doing is you're reading data from the source table, storing it in a data set. Then another job is reading data from your data set and storing and loading it to a target table. Now, what happens, let's say if the target job fails? If we did not have this job split into two portions, if we had just a single job in which you were reading data from the source and then loading it to another target table, then if the target load would have failed, you would again have to read in the job, which would again read from your source table and so on. So to minimize that extra processing that happens, we can use intermediate data sets. So now we have split the job into two steps. We read the data, put it in a data set. From the data set, we read the data and load it to the target table. Now, in this case, if the load job fails, we still have the data set which has already been read from the source in a data set. So we just need to rerun the target job. So that is one advantage. The database table can be reloaded after a failure without rereading the source data. Another advantage is that the dataset can be used by other jobs, right? So that dataset is reusable. And then, like, you have sometimes scenarios where your source database is available only for a limited time. You can only access it for a limited time. Or in other scenarios where it is available even by 24/7, you do not want to be hitting the source database too much because it would impact the performance of the source database. A source database could be an OLTP system, which is a transactional database. So like an ATM system where they need to display updated information real time to the users. So you do not want to be hitting such systems again and again. So you want to store your data in some kind of staging area, which could be a data set or a staging table, and you do not want to be hitting the system because it might slow down their performance. So that is where a data set can be useful. So those are your correct options. Now, which three features of datasets make them suitable for job restart point? So another similar question. Um, they are partitioned, so they are easy for Datastage to use to read. They use data types that are in parallel engine internal format, and they are persistent. So these are some of the characteristics of data sets that they're highlighting over here, and why they are good as restart points, because data sets can read them faster and they retain the partitioning. So those are the main points that you need to remember here. So go through all those options, and in these kind of scenarios where there are multiple options possible, you can actually go with an approach to um, pick out the wrong answers and eliminate them first, and then you'll be left with the right answer. So are they indexed for fast data access? No, there's nothing like that. The last option is they are compressed to minimize storage space, nothing like that. So those two are eliminated. The other ones seem right. So those are your correct answers. Okay, now moving on to the data transformation stage, which is the transformer, the most important stage. The transformer stage has a single input link. It can have any number of output links. It can also have a reject link. Now, it is important to understand what is the evaluation sequence in transformer. Now, again, transformer, I'll provide links to detailed videos on transformer if you are not comfortable with the use of transformer. But if you have been working as a database developer, you would have got multiple opportunities to work on the transformer stage. So here we are highlighting the important features that you need to know about transformer from a certification point of view, but I'll provide links to detailed videos so you can go and look at them and understand them in detail. So transformer stage has stage variables, it has constraints, it has column derivations. What is the evaluation sequence? You need to understand the evaluation sequence. So when you define the stage variables in a transformer state, the stage variable is the one that would be executed first. So whatever is your derivation, the stage variable, it would be calculated, stored to the stage variable, assigned to the stage variable. After that, your constraints would be evaluated. So why is it that the constraints are evaluated after the stage variable? Because constraints can use stage variable. So you can define a stage variable and use it in your constraint. After the constraints are evaluated for the output records, so you know which records to output to which output link, then it goes to the column derivations and executes them. Another important thing here that you need to remember is that stage variables are executed from top to bottom. And that is the key logic that you need to understand if you want to implement any functionality using the stage variables. They are implemented from top to bottom. So if you want to retain the value of the previous record and make some calculations of that sort, this is the important thing that you need to understand, that they're evaluated from top to bottom. That is the thing that you use to implement that kind of logic. Now, there are various options available in Datastage transformer. You have system variables, you can have derivations, you can have if-then else statements, you can have functions applied to your input column, you can use Datastage macros, and so on. So system variables, these are some kind of system variables: at false, at true, at in row num, out row num, number of partitions, which define the total number of partitions, partition number, which defines the partition number of that particular instance. Another favorite in the certification exam, so mostly there would be a question around this, which we'll see in the sample questions. Then there is a constrained otherwise link. So you just need to understand this as well. There are questions many times around this concept as well. So if you look at the transformer stage constraints window over here, you'll see that you can define the constraints over here. Now you have an option over here, otherwise or log. So what it basically does is, for the first two output links, it is checking for those conditions. So any input records that satisfy this condition would be output to output link 87. Any output input records that satisfy this condition would be output to DS link 94. Any input rows that do not satisfy any of these conditions, if you want to collect those records, you can specify the last link and specify or check this box otherwise or log. Okay. So what would happen is, all the records, input records that do not satisfy any of the condition in the links previous to this link would fall into this, would be collected by this output link. Thing to remember here is that this otherwise link should always be the last link in your transformer if you want to collect the records which have not satisfied any of the conditions, because it only considers the links which are above it or previous to that link in the link ordering. So let's say this DS link 96 was here, and you specified otherwise as the second output link, then what would happen is, only records that do not satisfy this condition from the previous link would be collected in the otherwise link. So it has to be the last link. Another way you can do this is, go to the constraint window and simply type otherwise. Instead of clicking on this text box, you can type otherwise. It would achieve the same purpose. This is obviously easier to do, right? Another important thing that has been coming nowadays in the certification exams are questions around these new functions. So they're not really new, but they uh, are being used more as we use the looping function in the transformer. So there are two functions. It's called key break detection. There's a function called last row in group, and there's a function called last row, which detects your end of data. So how are they useful? So if you look at this figure over here, you'll see that the last row in group function is used here. We are implementing some kind of looping over here. Okay. And it is used on the product ID column. So what it does is, if your input data is sorted and grouped or partitioned by the product ID column, okay, and you specify the last row in group function, whenever you reach the last row of that group of product ID, in that case, this would be set to 1. So it would know which is the last record in that group. So let's say you have 10 records with product ID as 1. So when you reach the 10th record of product ID 1, this last row in group function would be set. That means it would know that this is the last record in this group. After that, you have another group with product ID 2 with 5 records. When it reaches the 5th record of the second group with product ID as 2, again this would be set and it would identify the last record. So this can now be used to calculate running totals or the totals in a group and so on. So it's some kind of function that we used to do in the stage variables by storing the value of the previous record and then checking if the previous customer product ID value matches the product ID from the current record. So all that logic that we used to implement through the stage variables, it still needs to be implemented, but it's easier to identify the last row in this case using this function. So this is a very important function. It can be used to calculate the running totals as well. So you can keep on adding or you can keep on summing up the order value or something like that. And then when you reach the last record, you know that now you have to start once again from 0 to sum up the values because it's a new group now, right? So this is your last row in group function. Now we saw earlier that there's another function called the last row. Last row is basically the last row of your input data. All right. So it does not consider any particular group. It is the last row of your input data. So this is the kind of question you will get around these functions. Which of the following will determine the running row number within a group? Okay, so running row number, that should click in your mind that we are talking about either the last row in group or the last row function. All right. So in a transformer, we know there's only one option, the last row in group function. So you can use a sort stage prior to the transformer stage, or you can use an end stage sort to sort your data. That would be your key break column. It is called key break detection. So key is the one that you partition on. So in terms of data stage, that is the key column on which you are grouping on. So it is called key break detection, as well as soon as the key value changes or as soon as it reaches the last value in the key, it can be identified using this function. Okay, another question around transformer, another important question actually, your input rows contain customer data from a variety of locations. You are reading those rows from a specified location based on a parameter value. So we have different locations and we have a parameter value for the locations, and whatever is the value in that parameter, based on that we are reading the input data. Now, so that is the parameter value is a changing value. It's a dynamic value that you can pass at runtime. Now you decide whether to use a transformer or filter stage to accomplish this. So whenever there is a condition like this, a transformer versus a filter stage, a transformer stage is the one that you should prefer over a filter stage in these scenarios, especially using a parameter file or something like that, where you are dealing with dynamic values, because a transformer yields better performance than a filter stage. So you should remember this whenever you are working with dynamic values, parameter values, a transformer is going to yield a better performance than a filter stage, because the filter clause interprets all these parameter values at runtime, which is an additional overhead for the data stage job. So whenever you are dealing with dynamic or parameter values, a transformer stage has to be preferred over a filter stage. A transformer stage can perform the same function as a filter stage by defining constraints, which a filter stage defines in its where clauses. You can define those constraints as constraints in transformer stage and limit the number of records going to your output stage. Okay. Now, in a transformer, you add a new column to an output link named job name, right? It contains the name of the job that is running. What can be used to derive that column? So simple. It is simply asking that we want to print the job name to the output. What kind can we use a data stage function, a variable, or a data stage macro? So you have to just know that there are these various macro values available. So we just saw the system variable, and then you have these macro values available. So you can identify the host name, the job controller, invocation ID, job name, start date, start timestamp, wave number, project name, and so on. So especially for like audit columns, these macro values are very useful. Also, when you like whenever you're loading data to a target table, there's something like a load date or something. So this is used dsjob start timestamp, that is very commonly used. So just be aware of that these are data stage macros, and they can be used in a data stage job to get the values of all these parameters. Now in a transformer, you add a new column to an output link. Okay, that is the same question, sorry. Now, another thing that you should be aware of is again some environment variables that are related to a transformer. So the question here is, which of the following is true about transformer stage when apt transform compile old null handling is said? Okay. So first of all, to be able to answer this question, we need to understand what is this environment variable. So this environment variable actually would, if you set this environment variable, as the name says, it is apt transform compile old null handling. So what the way Datastage used to handle in previous versions of Datastage. So what used to happen is in previous versions of Datastage uh, is basically that if you did not handle the null value manually by using all those options that we saw earlier, if you did not handle the null value manually, then you would have the record that would either the job would abort or it would be collected in the reject link if you have a reject link coming out of the transformer stage. Now in the new version of Datastage, what happens is if you have a null value in the source and you are performing some operation on it, whatever it is, which results in a null in the output, so you cannot perform an operation or nothing, then it just passes on the null value to the output. So the record is not dropped, or the record is not, the job is not aborted. It is not connected as a reject in the reject link. Um, it is moved to the output stage or the output link as a null value. So again, that being said, even in the newer versions of Datastage, this null is being handled this way, but that makes like it's a good idea to again go and explicitly handle null, because you want to be sure how you want to be dealing with the null values. If you do not define them, Datastage is by default defaulting it all to null, which might mess up your results. Okay, so it's a good idea to be again cautious about how you are dealing with null. Sometimes for some reasons you might want, that is why Datastage has given this option that you can go back to the old null handling process. So in that case, if you do not explicitly handle the null, then the job itself would either reject that link or drop that link, or result in a job abortion. So in that case, you might catch the error while you're testing your Datastage job, that okay, there were nulls in the source and they were not being handled properly. So I need to handle them properly. So in those kind of scenarios, you might need to use this this environment variable. So the correct answer in this case is, if an input column that is used in the derivation expression contains a null value, then the row will be dropped, a reject link, or if your reject link has been identified, it would be rejected. So these are the two options that would happen if you set this to true. APT transform compile old null handling, the record would be dropped, or uh, it would be diverted to the reject link. Okay, so moving on quickly to job design now. Shared containers. Now, these are an interesting part of how you design your Datastage jobs. Shared containers advantage obviously is, as the name suggests, they can be shared across jobs, so they are reusable. Okay, excuse me. So you can basically have a part of your job logic put in your shared container, and then you can use that shared container. You can call that shared container from a parallel job, or you can uh, call it from different parallel jobs actually and make it reusable. So that is the advantage of having a shared container. So let's quickly see how you can define a shared container. So we have this job, okay, that's a parallel job, and we have an input and an output, and we have some transformation happening in between. Okay, so in the transformer, we are just reading the input columns, applying some kind of trim function, and then in the sort operation, we are just sorting by the customer ID and mapping the columns to the output. Now this, let's see, we need to do this operation again and again multiple times for different sources and so on, or different files and so on. So we want to convert this into a reusable component. So just select the portion of the job you want to convert, go to edit, go to construct container, select shared, okay. It will give you this warning message. You can just click on yes, and then when you say yes, it would ask you to save the shared container somewhere, and it would convert it into a shared container. So now that part of the data stage job has been converted into a shared container. So you still have the input and output, and then you have a shared container in between, right? So now if you click on this shared container, so just double click on this shared container, and you can see that this is the kind of stage editor. You have your input link where it says that your input link is mapped to this, and you have your columns defined. You can validate your input link as well. And then in the outputs, you have your output link mapped to this. So similar to the input link. If you right click on this, you can actually go to the shared container. So just click on open. And this is the shared container which has been generated. So you can see that the input and output stages appended to this, and then you have that same logic over here. So you have your customer IDs being trimmed, and then a sort operation happening, and so on. So this is the advantage of your shared container. Now these can be especially useful if we would use runtime column propagation, because then what would happen, we would not need to define the input and output structure, because Datastage job would automatically propagate those columns. And let's say my requirement is just to propagate the input columns to output columns, and there is a common, and just generate a row ID or something like that. Okay, so a surrogate key or something. So in that case, my source might have different structures, but I just need to simply move it from source to target. So why design multiple jobs around it? I can just define this mapping into a parallel container. So just map it, the input columns to output columns, probably some generate a surrogate key, and sort by the surrogate key, or perform some operation that is common to all those files, and put it in a shared container. And then from your jobs that you define, you can just keep on calling this shared container. Okay, now what is the advantage? You can call this shared container from multiple jobs. If you need to make any job in the job logic of the shared container, just go to the shared container, make that change in the job logic. That would be available to all the other jobs that are calling this shared container. The only thing you need to keep in mind is that when you make any job, any change to your shared container, then you need to compile the shared container and compile all the jobs that are using that shared container. So these are just more details of how you can create a shared container. You can have an input interface stage, output interface stage, and you have input columns defined. You are just doing some operations on the output columns, okay? And the other columns are propagated by RCP. In this case, just use your shared containers, all right? So same things over here. Now some sample questions around shared containers. Which two statements about shared containers are true? So shared containers can be used to make job components that are reusable and can be used throughout the project. That is one thing that we already know. And server shared containers allow for Datastage server edition components to be called in parallel jobs. So this is another feature wherein you can actually have a server shared container and not a parallel shared container. You can still call it through a parallel job. Okay. Okay. So job design, data masking. Now this is one of the interesting topics. And as developers, many times we're not working with this particular aspect of data stage. We're not using the data masking stage. So this is encrypting the data, which is confidential data or sensitive data. We do not want, it is some customer specific data. We do not want anybody to see it. So we need to encrypt it or mask it. So that is where this stage becomes useful, and it's a data masking stage. So okay, this figure is not clear, but what is happening is basically we're just masking the data, and there are various options that are available in Datastage to help us do that. So let's go on to further slides, and this will be more clear. So before that, we need to understand that the data masking stage requires some Optim data privacy providers. It is a library to mask privacy data, so you need access to this and you need to download this. Okay, now a data masking stage is actually a stage in Datastage. All right, it can have an input link, it can have an output link, it can also have a reject link. This is how a data masking stage looks like. Okay, you have a source file, you have an output file, and you can have a reject file link. coming from the data masking stage. So you are reading a source data here, you're applying your masking policy over here, outputting the encrypted data over here or the masked data over here, and rejecting any invalid data over here. Okay, so there are different kinds of what are called as masking policies available, data masking policies available in this stage through data stage. Now, this is an example of credit card masking policy. It has some options that you can use. All right. So there's this original value. Let's say there's the original value of credit card, which is 34001100000063. There are three options that we can use for this. There's something called the repeatable masking that would simply like change the numbers over here. So you can see that 3400 is the same. All the other values have been changed to some random number. You can have use 4 issuer digits. So what is happening over here is that again it is using the first two numbers and then it has changed the other numbers altogether. Use 6 issuer digits. In this case, what is happening is that it has used the first 6 digits as it is from the credit card number and changed the other digits. So this is how you can mask your data. One of the other masking policies that is available is relating to the email addresses. So you can have different options again with the email addresses for all. Okay. So your original value is this louis.maria@university.edu. So everything has to be masked. So it has converted the whole thing into some random characters. If the username only needs to be masked, it has just masked the username. Your domain is still the same, university.edu. If it just needs to mask the domain name, then your user ID remains the same, only your domain name has been masked. So you have different options you can choose as per your requirement. Okay, so let's look at this, how it actually looks like in practice. So this is your data masking stage. You can just click on it, double click on it, and this is how the stage looks like. And what is important to us here is to go to the, okay, let's check the input. Input just has the column. So you have customer ID, customer name, and credit card. And we'll see if we can use a credit card masking policy over here. You go to the output and then you go to your columns. So in the output, we want the data to be masked. Now you'll see something like masking policy written over here and masking policy editor over here. If you click on masking policy editor, it will give you a list of the output columns that you have. So we have 3 output columns. Which one do you want to mask data on? So we want to mask it on credit card. And then it will give you all these options of masking policies which are available. Okay. So you can choose the masking policy that is as per your requirement. Okay. So we have credit card number. And then you can specify the parameter that we saw earlier. Do you want it to be repeatable masking? Do you want it to be a 4 issuer digits? Do you want it to be a 6 issuer digits? And so on. Okay. And you'll see in the masking policy that something has been written away. So CCN used for issuer. So that is some kind of code for the masking policy that we just selected. So this is how you can use the data masking stage. Very simple and straightforward to use. You just have to go to the masking policy editor and choose the appropriate masking policy that is needed. All right. Now, kind of question that might appear in your certification exam. In the masking policy editor, in the data masking stage of your job, you have specified for a column containing credit card numbers, the replacement masking policy. For the copy option, you have specified 1, 2, 3, 4, okay, whatever. What changes will be made to the credit card number to mask it? Okay. So you have to understand here, the 2 digits starting at digit 1 and the 4 digits starting at digit 3 will be randomly changed. The rest of the digits will remain the same. Okay, so this, because you have specified the replacement masking policy and you have said 1, 2. So this is how it works. The 2 digits starting at digit 1. Okay, so this is the static position and these are the number of digits. And the 4 digits starting at number 3 will be randomly changed. All the remaining digits will be the same. So this is how you can specify the repeatable masking link. Okay, and this is how you specify the options. So again, you need to go through all those policies and understand them at a higher level at least. So the national ID is just take an understanding of the national IDs. The important ones here are the credit card ones with its options, then the email addresses. So for email addresses also there are multiple, so stick to email address, and then the age one. Okay, so these are the important ones. Otherwise, there are a lot of data masking policies. Be aware um, on a summarized level of how, or a high level on how all these policies work, but know the details at least of the credit card policy and the national ID. Just be aware at a higher level, and the email one and the data age one, right? Okay, so job control and runtime management. This is another important topic, and there might be a few questions around it. We are going to discuss message handlers in this. So message handler, you might or might not be aware of message handlers. Message handlers simply means that you have when you run a data stage job or execute a data stage job, a director log is generated, right? If you go to the director log, you'll see that some of the messages are of the kind information, which are green, okay, which are okay, and they just log the informational message. Some of the messages in the datastage director log are yellow, which are warnings. Okay, so your job will finish with a status of finished with warnings, and some of them are fatal red. Okay, so your job would actually abort in that case. So sometimes it is actually okay for us to have a warning around some stage. Okay, so we do not really care, and we have validated that the data flow is all right, and we are okay to go with the warning. So sometimes what we want to do is actually mark or promote those warning messages to informational messages, so that the job finishes with the status of finish instead of finishing with the status of finish with warnings. Now, why do we need to do that? It happens because in the sequencer, all right, you have this option. You can define that what should be the completion status of the previous job. And especially in case of server jobs, if your job finishes with warnings and it is considered as a fatal error, okay, so the next job in the sequencer would not be triggered. So in those cases, it is important to actually go and promote those acceptable warning messages as the information messages. That is where message handler comes in handy. This should only be done when you have no way of dealing with those warning messages in your data stage job design. You cannot eliminate those data stage warning messages through correcting your data stage job design. So it is only to be done when it is a valid warning message that cannot be eliminated in any other way. Now, these message handlers can be defined at two levels, at project level and at a job level as well. There are three actions that you can actually choose. You can choose to suppress those messages from the log, so they will not be written to the log at all. You can promote them to warning. So you have an informational message, you can actually promote it to warning. Okay, so it is called promotion. When you change an informational message to warning, it is actually promotion. So make note of the word promote here. It is not a demotion, it's a promotion. You can demote to informational. So you have a warning message, you can demote it to informational. The message ID, type, example, everything will be displayed. You have to click on add rule. So we'll see how. So this is how it actually appears, your message handler window. So you have to add rule to your message handler. You have to choose an action. So we are saying suppress from the log. Okay, there would be some message ID and message type is info. We are saying suppress it from the log. So you can go to your directory log which has been generated. You can choose a particular message ID and just select this option of suppress from log and add this rule. So the next time the job is run, these kind of messages would be suppressed. You can also edit the message handlers if you need to. So all these messages, these are warning. We have seen we have suppressed all these messages from the log in this case. The message handler file format is simple. It has the extension of .msh and it is stored in this path over here. Okay, the format is like message ID, then message type, then you have the type again, which is 1 for informational messages and 2 for warning messages. Then you have the action specified by 1, 2, or 3. 1 is suppress, 2 is promote, promote to warning, 3 is demote, demote to informational, and then you have the example text of the message. So this is your message ID, right? Till this point, then one is your type of the message. One here is your action that you're going to take on that message, and this is your example text of the message. So let's look here how we can define the message handler options. Go to tools. We are in the Datastage designer window. You have this option message handler manager. So go to the message handler manager, and then you have this option to add a chosen message handler. So if you've already done your Datastage job, there would be some existing messages that you can edit, or you can go to new and then specify a new message handler rule. So just go to new over here, put the message ID over there, and then you can specify an action, which as we saw earlier, three options: suppress from log, promote to warning, and demote to informational. Which of the following actions are available when editing a message handler? So we already know you have the option of promote to warning. Okay, so you only have the option of promote to warning, because you cannot promote to informational or demote to warning. It is called demote to informational and so on. So your correct answer here is promote to warning. Okay. Okay, so next related topic is your dsjob. So if you have experience developing Datastage jobs, and if you have developed Datastage jobs, then you need to execute them when you move them into production, like a batch in a sequence or so on. So you do not actually want to go to the director and run them manually, or schedule them from the Datastage director if there are a lot of jobs. What you do is actually create Unix scripts to run those jobs through the Unix server or the Linux server, and then you can schedule those Unix scripts in an external scheduler or through cron or so on. Now to run it, any Datastage job from a command line, you have to use the dsjob command line utility, right? Now, dsjob command line utility again can perform a variety of functions. The most important use of the dsjob is to run the Datastage job from the Unix or the Linux command line. But there are other purposes of the dsjob as well. You can start, you can stop, you can validate, you can reset the jobs, then you can stop a job, you can list the projects, list jobs, list stages, list links. So many options are available with the dsjob command. So you should have basic knowledge of all these options, though practically the one that is used is mostly the dsjob run command. That is the only one that is used, but it's good to have at least an understanding of all these options which are available from a certification point of view. So I'll be sharing all this information with you. You can just go through it. This is simply you need to go through it and be aware of all these different options that are available. Okay, setting an alias for a job, displaying job information, stage information, link information, parameter information, adding a log entry, displaying a short log entry. So there are multiple options that are available. You can even generate a report using the dsjob command, right? Now this is a link which has the latest information as related to 11.7. So you should be referring to this link whenever you're studying for the certification exam. I'll be sharing everything, so do not worry. And the kind of questions which are asked in this case are this: which of the following will run the Datastage job in the Unix environment? So they have given you a domain ID, they have given you server details and the user. Okay, so again, as you see over here, they have asked about running the Datastage job only. So focus on this particular option of dsjob run, but be aware about the other options as well. So this is on the IBM website. I've taken it from there. This is how you can specify, if you want to specify the domain name as well. So it can either be a URL or a domain name you can give. You have to write user, then username, password, then server, then engine name. Okay, so you can change the order as well of all these things, but all these options should be there. Okay, so this is not the right one. You do not have to write user name over here. You have to use user. Okay, so it should have information like domain, user, password, and server. So what they're trying to confuse you here with is the different options with the user. So they have used user over here, then user ID, then user name, then user again over here. Okay, so it has to be either the first one or the last one which is correct. This is not the correct one which is highlighted. Now in the first one, if we look, we have given the user information, but we have not given the password information. So the correct option is the last one, where we have the domain information, we have the server information, we have the user information, we have the password information, and then we have uh, written down the job, run, and the job name. Okay, so that is your option. Okay, so we have 8 minutes left. Okay, let's take an example of this real-time processing. Okay, so this is also important to know real-time processing. What does real-time processing mean? Real-time processing means that you want to connect directly, or you want to run your Datastage job either as a service, or you want to connect to other services directly. So that is your real-time processing that happens. As Datastage developers, there might or might not be requirements in a project to deal with real-time processing. So I mean, there might be limited knowledge that we have around these topics, but from a certification point of view, again, we need to know these things. So here's an example of connecting to the web services. Now, what are web services? Web services is any data that is coming from a website. That is a web service. Okay. Now, what is our requirement in a Datastage job? That we get this data from the web service, read the data from the web service. So whatever is coming from a website, we want to read that data, then process it and store it in some target table or target data set. That is the requirement of a Datastage job. So how do you connect to these web services in that case? There are actually two options. You can try to connect to the web service directly. Okay, that is one option that is more suited for real-time processing. Another option that has been there for quite a while is using the MQ connector. So in that case, your web service actually has to generate MQ messages, and you'll be reading the MQ messages in your Datastage job. That would have all the information coming from the website and processing it. So MQ messages would not be that much real time. They would more be like batch messages. You have to define a lot of things. You have to set up your MQ connectors, MQ message queue, for all those things have to be set up. Then you'll be able to use the MQ connector. You want to connect to the web service directly, that is also possible using the web service transformer stage. Now these are not very advanced options in Datastage, so they are not very easy to use, and you have to change a lot of, you have to do a lot of say changing of the parameters and things like that to make them work correctly. But MQ connector is quite stable. It has been there for a while. Okay, even for staging areas, mostly we are using MQ connectors because data is coming from some online website, and that is a source of data, initial source of data. So MQ connector is more widely used. Okay, let's just take a look at the options available for these particular stages. So let's go to the MQ connector stage and just see what are the options. So here you just have to define your mode, which can be server or client. If you change your mode, some options would change, but basically the important things you need to define are your queue manager, your channel types, your queue name, your access mode, your wait time. So some of these things you can leave at a default value, but the other things are important. So message queue, all these information actually you will get from your source team. So whoever is dealing with the website, they'll be providing you with all that information. Now if you have a web services transformer, okay, so actually what happens in this is that you have to, okay, let's go back a bit and go to the web service transformer. So this is how the window opens. Now you have to first select a web service operation. When you click on that, this window will open. Now what you need to do here is actually import a WSDL. Okay, a WSDL is your kind of schema file for the web service. So you need to import those details so you know which columns have what kind of information and what kind of information you need to read. So you can just go to the internet or go to the location that they have provided. Again, your web service team would be providing that information. Click on advanced and provide all this information: service name, port address, port name, WSDL address, SOAP action, operational styles. Important ones there are your service name, your WSDL name, your port name, and all these things. Now, web services client, it has a similar interface to your web services transformer. It is used to connect directly to your web service. That means you're connecting directly to a website. Okay. So now again, okay, let's go back here. And okay, you can enter all that information in the advanced as we just saw, right? And then service name, port address, all this information you'll have to ask your web service team to provide. And because it involves the coordination of two different teams, it is sometimes it's difficult to set these up correctly because they do not have an understanding of what Datastage requires. Now the other options as well you can see. So if you click on the options tab, then you have these options of error handling, fatal, info, warning, trace. Many times it would be fatal. You can just keep it to info to be able to read from the web service. So you have to play around with these things. They are not very stable as such. Can give your security proxy if needed, and you can set your advanced settings. So just be aware that these stages are there, which will allow you to connect to the web services. But WebSphere MQ connector is the one that has been more widely used, but you can connect directly to your web service as well using these two stages. Okay, so MQ connector. Let's take an example over here. So what we have specified, our mode is client, the queue manager is IBM test. You need to provide the credentials to log into your queue manager. You need to define a channel name. Your transport type is TCP. Your connection name is your server IP, and then your port number probably. You have to define a queue name. You have to define your access mode. You have to define your wait time, message quantity. All these things are mostly predefined. So the important information is all over here. Again, you don't have this information. You have to ask your MQ team to provide all this information. Okay. When you will import the data, this is how it looks like. So you have your column, okay, some ID column kind of thing. And then you have a message ID. So it is of this format. You have to select data element. So when you'll import the data, it would actually show it like this when you specify all those parameters. This is known as a payload, which has all the data from that particular message. So an MQ or a message is nothing that is, it is simply a message in an XML format or an HTML format that is generated by the website. Okay, and for any kind of write operation or any for every transaction basically that takes place, and it can have a message ID, and it can have some data, the whole data concatenated into a single column, which is known as a payload. So that is the thing that we're talking about here. And when we say that we have to import Western, when we have to use the web services client stage or so on. So this is basically what a WSDL looks like. Okay, so it has your metadata from the web service. So it defines all these things as you would define in an HTML page when you build a web design or web page for data entry. Okay, so it will have all this kind of information that is there. So this would basically define your metadata based on which you'll be reading the data from the web service. So that is why it is like a metadata import or column structure import before you can read data from the web service. So this is about the WSDL file. So the first topic that we are going to pick today is from the job management and deployment, and we are going to pick the topic of importing and exporting jobs. Now, if you have worked as a Datastage developer, many times you would have imported or exported the Datastage jobs. So the first way to do that obviously is through the Datastage designer window. So this is your Datastage designer, and you can see that in the menu bar above you have two options of importing and exporting. If you go to export and select your Datastage components over here, Then this is the repository export box that would come up, and this has many options. You can actually go and add your jobs over here. You'll be able to see the jobs that you have added. Then you have different options like exclude read-only items or include dependent items and so on. So we'll take a look at these in just a minute. So once you click on the add button over here, you can add the job that you want to export. So this is a job. It is a test job one that we're going to export, and this is included here. Um, you can select your job. If there are multiple jobs, you can select on the select all button, so those jobs will get selected. Now there are some options over here, job components to export, and there are three options. Do you want to export them with the executables or without design? Executable is basically a ready compiled form of the job, so the job would be in compiled form when it is exported to the or imported to the new server. You have the other options as the type of export. So you can either export as a DSX file, which is the most common form of export. You can also export as an XML file. You can here choose the path to which you want to save your DSX file or the XML file that you are exporting. So you can define your path on your local machine. Then you have these two options, exclude read-only items. So if your job is referencing any read-only items, do you want to exclude them or include them in your job DSX? And the other option is to include dependent items. So let's say you are importing a sequencer job. A sequencer job is in turn calling two more jobs. So when you export that sequencer job, if you click on this include dependent items, then those two jobs will also be exported and included in the same DSX file. So you have to choose this option wisely because many times you might have just changed the sequencer. Those other common jobs might be used by the other projects or modules as well, and there might not be any changes, so you would not be wanting to override them in the upper environment like a production environment or a test environment. So be careful with this particular option. You can append to an existing file. So if you already have a DSX file, you can append this code itself to that DSX file. So you can have multiple jobs in the same DSX file. Now, if you want to import the job, again, you have this option over here in the menu bar. You have the import icon. So just go to import and click on Datastage components. That is what we are trying to import over here. Once you click on import, this box would pop up, which is the Datastage repository import. You can again specify the location from which you want to import your job. So you have your DSX lying somewhere on your local machine, local Windows machine. You want to import that DSX now into a new server. So go to that path where you have that DSX. Then there are other various options over here. And again, be careful about all these options. You can have an option called import all, which would just import all the jobs that you have in the DSX. You can also choose import selected. If you choose this, then it will give you a pop-up box where you have the option to choose which jobs out of all the jobs included in that DSX you want to import. So that is kind of a check. So it's good to have this option sometimes as import selected, because then you can have a double check on the jobs that you actually want to import and not mistakenly overwrite anywhere. So override without query. Now let's say there's a job already on your new server, and now you have made some changes in the job in the development server and you want to import that job into the test server. The test server already had that job, so the job name would be the same. So once you try to import that job from development server into the test server, this would give you a pop-up asking that this job already exists. Do you want to override that job? So we want that pop-up again as a double check that we are importing the right job. So if you check this box override without query, that query would not be asked to you and it would just in the backend override the job. Then perform impact analysis. If especially there are large jobs that you are trying to import and it's just the code that you are importing, you do not want to perform any impact analysis because that takes a lot of time. So it depends again on your requirements. If it's a really sensitive job and you think you really want to analyze that what impact it might have, what other jobs it might be impacting, then you can click on this. It is checked by default, but if you are just importing a job, you're sure of what you are importing, then you can uncheck this because it takes a lot of time, especially if the job is huge and it has many stages included in it. Add environment variables to project. So if there are any new environment variables that are being referenced by the job that you're trying to import, then do you want them to be added to the project automatically? You can select that option. Again, it is not checked by default, and you can like manually actually think about which environment variables need to be added and add them manually. That would be a better practice because then you can track what you have added to the new environment, because this, if you check this, Dataset should do it automatically and you might lose track, and then when you try to move it to another environment like the production environment, you might forget what you have added or not added, and it might impact it. So whenever you're doing a deployment, a best practice is to have a deployment checklist with you with what all components you are deploying, along with your Unix scripts, along with your parameter sets, along with your environment variables, and all the changes to any stored procedures and so on. Now, another way to import is through the Information Server Manager. Now, in many projects, it is defined that only Datastage admins who are doing the deployments or any production support team who's doing the deployments would have access to the Information Server Manager. But sometimes developers also have access to the Information Server Manager. And the way you make or import or export projects over here is that you go and make packages. Now, another thing that is different here is that the extension here is .isx and not .dsx as we had when we exported manually from the designer. So you can just go File, New, and select Package. And when you say Package, then it gives you an option to choose the different jobs from the different repositories that you would have added over here. Repositories are nothing but your projects, and you can add your different jobs over here. You can create a package and then import that package into the new server. Another interesting feature of the Information Server Manager is that you can synchronize it with a source control system like a CVS system. So you can maintain some kind of version history over here, and this can directly integrate with your source control system. Now, let's say we want to automate the whole thing. We do not want to go manually and select the jobs from the designer or create a package to the manager. Then there are some command line options as well. And the command line option involves the IS tool command line interface. So IS tool command line, you can import or export projects. These are the syntaxes that you need to follow to write an import command or an export command. And just take a look at these syntaxes because there might be questions around this in the certification exam. So this is an important part. So just take note of the syntax, and important thing over here is the archive command, archive option over here, and then you give the file name and path. So archive is where all your code is going to go with this command. Okay, so it's not the typical archive. Archive is the file that you are going to create with the code that you're trying to import or export. All right. And similarly for export, the install command, this is the command. You have the -archive file name and path, so where you want to import the code and the file name and other options over here. Now, another important topic in for the certification is that which kind of assets can be exported using the archive files or the IS tools, and in which order should you be exporting them. So just take a look at this line and read it before you go for your certification. So these are the assets you can export, and you should try to export them in the following order: users and groups, common metadata, then your data stage and quality stage assets, then any reports, then any information analyzer assets, then these fast track assets, and so on. So just keep in mind this order in which you need to export your assets or migrate your assets. Now there is another command, that is the dscmd import command. The dscmd import command can be used to import or export projects. Again, it runs in the backend. You just provide the username and password to this command itself, so it can be executed unmonitored, whereas the previous command that we saw has to be executed, like it will give you an interactive box. You might need to enter your username and password over there, so it has to be monitored. This command can run unmonitored, so you can use this in your Unix shell scripts for creating the export and import scripts. So this is your dscmd import command, and similarly you have the dscmd export command as well. Now these are the assets which can be exported. So there might be questions like that, can this asset be exported through the dscmd or the is-tool CLI interface? Then you have to make sure that it lies within these list of assets, only then it can be exported. Okay, so source control we've already seen. Okay, so this is a sample question that you would get in your certification exam. So the question goes like, archive files can contain assets from multiple exports of multiple projects. From an archive file with the is-tool command, what is the order of asset types below would yield the best performance? So this is around the same topic that we saw earlier, the order of the assets that should be imported or exported. So they have mentioned users and groups, common metadata, InfoSphere, Datastage, and quality stage assets, reports, custom attributes, and so on. So from that list, if you go back to that list, then you'll find the first was users and groups, then common metadata, then InfoSphere data stage and quality stage assets, reports, information analyzer, fast track governance, catalog data sources, mapping documents, and so on. So let's go back to our question and see what they're asking for. Okay, so users and groups we saw were the first one. Users and groups are in the first option and in the last option. So B and C are automatically eliminated at this point. Then after users and groups, it was common metadata that is also there in both the options, and InfoSphere data stage and quality stage assets also there in both of the options. Then in this option we have reports, whereas in this we have custom attributes. So now we have to make sure whether the fourth in the order was reports or custom attributes. So let's go back and see. So here we have reports. All right. So the fourth is going to be a reports. So A is going to be a first. A is going to be a correct answer over here because this has all the assets in the correct order. So these are the kind of questions you would get around the import-export of Datastage jobs. Okay, moving on to another section, which is metadata. So talking about operational metadata. So operational metadata is collected for all these situations. It is when the job has run, it has failed, it had warnings, which database tables or files were read from, written to, or referenced, how many records were read, how many records were written, when did the job start, when did the job finish, what were the stages and links used in the job, what was the project that the job was in, the computer or the system that the job ran on, what were the runtime parameters, and the invocation ID if it's a multiple instance job, any other information about the job. So that this is all the operational metadata. This is what is called the operational metadata. Now, operational metadata has to be enabled. It can be enabled either at the project level or at the job itself. Operational metadata is collected in an XML file. If you run a job, an XML file would be created for that job. If you run multiple jobs or a sequence of jobs, a separate XML file would be created for each run of the job. Now we have collected all that operational metadata. What to do with this metadata? This metadata can be used for analysis using the IBM InfoSphere Metadata Asset Manager, or you can build reports out of this metadata and see how much time, how this job was running. So it's basically for analysis purposes. You can see that this job is taking more time to run. This is the time it typically starts to run. This is the time it typically ends its run. So you can analyze your system resources accordingly, your job performance accordingly. So you can also build reports on this operational metadata using the IBM InfoSphere Information Server Web Console. So you can see that now we're using different components of the InfoSphere suite for accessing the same operational metadata. So it is shared across different components of the InfoSphere suite. Now, if the operational metadata is not enabled at the project level, there is an option to enable it at the job level. The way you do that is go to the General tab of the Job Run Options dialog box in the Director client. So it is not the Designer client, it is a Director client. Okay. You can also deselect it by unchecking the same option. So again, this is something that you need to remember, how you can enable operational metadata. It actually needs to be enabled. It is not enabled by default. You can enable it either at the project level or the job level. If you are trying to enable it at the job level, it has to be done in the Datastage director during the job run options dialog box in the director client. Okay, so let's look at a question that might come on this topic. So in order to collect operational metadata, you must do which of the following? So these are your various options. So in order to collect operational metadata, we know that it needs to be enabled, and we know that it needs to be enabled either at the project level or at the job level. So accordingly, we have to analyze different options. The first one says enable generate operational metadata in the execution tab in the designer client. So designer client, we never had to do anything. So first option is eliminated. Second option is generate operational metadata in the general tab of the project properties using the director client. Project properties, there was nothing like that. So even the second option is eliminated. Enable record job performance data in the general tab of the properties using the administrator client. So this is also not right. We have not learned anything like that. The fourth option is enable generate operational metadata in the general tab of the job run options dialog box in the director client. This is what we just saw. So this is going to be your correct answer. So there are small things that they pick for the certification. So you have to be careful when you're reading about some particular topic, especially topics that you might not have worked around that much as a developer. So these are the small sentences. So whatever they have given in the documentation for Datastage and the components related to InfoSphere Datastage, I mean, they pick up from the sentences that are mentioned in that document on the important features. So whenever you're reading, read it twice so that you remember that, okay, at least mark the important points that you're reading if you're reading from the documentation, and make notes and read them again before your certification exam so that you remember those important lines that they have mentioned, because there might be questions around those. The correct answer is written as B over here, which is incorrect. Correct answer is not B. Okay, it is not B. It is D, right? The correct answer is D. So the option in this slide is wrong. The correct answer is D. Okay. Okay, moving on to parameter set and values. A parameter set is a very important characteristic while you are designing a Datastage job. And this is because you can group multiple parameters in a parameter set. Now in this figure you can see that there is a parameter set that is being created, and it has parameters like the DSN, the user, and there is some environment variable that we're trying to add over here. So these are basically related to some database connections. So instead of having separate parameters every time defined in a job, we can just reference to this parameter set, which has a group of parameters, and it can be used across jobs. Okay, so that is the most important part. It can be used across jobs, so it has reusability. If there are any changes that you need to make in any of the parameters or parameter values over here, you can just go to the parameter set and make that change instead of having to go to each of the job and make that change. So that saves a lot of effort. That is why having the parameter set is a good idea. Now, what are these value files then? So you can see that there are different tabs over here. Parameter tabs, you can define the parameters you want in your parameter set. In the values file, you can define different value files, and you can define different values for all those parameters that you define in this parameter set. Now, how is this advantageous? The most common use of the value files is for deployment while deploying to different environments. So you have a development environment, you have a test environment, you have a production environment. Obviously, the database connections are different for all those environments. So now you can just reference the correct value file in that particular environment from this parameter set and run it in that environment. You don't need to go to the job and change the values of your database credentials to connect to that particular uh, database in that environment. So that this is the most common use of the value file, that you can define multiple values to be used across different environments, and you can just reference that value file from the parameter set and run that job. So no changes to be made at all. The only thing that you need to do is put correct values in the value file, which is a one-time activity. You can do it while you are doing your first time migration of your parameter set, and then you do not need to make any changes to any of the jobs for the new database credentials. Okay, so a simple question around this. A parameter set is a named object that can contain which of the following. So they've given you multiple options. A parameter set can contain multiple parameters and only one value file. So it can contain multiple parameters. That is the advantage of having a parameter set, that you can group a number of parameters together. But if it has only one value file, it loses its advantage because we need multiple value files to be referenced in different environments. So option A is incorrect. Only one parameter and only one value file, this is totally incorrect. Multiple parameters and multiple value files, this is correct. Only one parameter and multiple value files, that is also incorrect. So we have to look for multiple parameters as well as multiple value files. So option C is the correct answer over here. Okay. Now, moving on to another important topic, which is data transformation, and which is a topic that you might be most familiar with as a Datastage developer. Slowly changing dimension. Now, if you're working in any kind of data warehousing project, then this is one of the most important kind of implementations that you need to do. Now, this can be done in various ways, and we have detailed videos on implementing the slowly changing dimension using the SCD stage and the change capture stage on a YouTube video. So I'll be providing links to those as well. So you can go and follow them if you're not sure of how to use these stages. But in this session, we'll be covering the important points around those stages and the ones that are useful from a certification perspective. So this is your slowly changing dimension stage, the most important window in the slowly changing dimension stage if you're trying to use it. A slowly changing dimension stage has to be used whenever you're trying to update a slowly changing dimension in your target model. All right, so you have an incoming stream of data. You already have some data in your dimension. You want to compare your incoming stream and see if there are any updates, if there are any new records which need to be correspondingly updated in your target slowly changing dimension. So if you look at this window, you'll see that this is your primary link. So this is the data that is coming from your source. Now these are the columns that we have in the output, and you'll see over here that there is a column called derivation where you can map these columns or give them constant values. And then you have some column called the purpose. These are purpose codes, which are the most important aspects of a slowly changing dimension. And then you have something called the expire. So for every column, you can assign it some kind of purpose code. Important columns that you would always have in a slowly changing dimension are surrogate key. Okay, because we are trying to keep the history, we need to have a surrogate key column in a slowly changing dimension to identify a unique record. So whatever is your surrogate key for the target table, you have to assign it the purpose code of surrogate key. Okay. Then you might have other key columns which are important from a business perspective. So those are business key columns, like a customer name column or a customer ID column, which is a customer employee number. sorry, let's take the example of an employee table. So let's say employee ID would be a surrogate key, employee number would be a business key, because we are not defining unique records based on in the table based on the employee number, because it might have different records, because we're maintaining history. So for the same employee, if something changes, we'll have another record for the same employee number. So in terms of database, unique records are as per the surrogate key, all right, which would be your employee ID. Then your business key would be your employee number, because many of your derivations would be based on that, right? Then you have some other columns which you can define as either type 1 or type 2 based on whether you want to retain the history for that column or not. So in the same dimension table, we might have different columns, and we might want to retain the history of a column called description. Okay, so we want, if the brand description changes, we want to see, right? But if the brand changes, we just want to update the brand. Okay, so we do not want to retain any history. So based on the requirements, you have to define the type 1 and type 2 over here. Then you have to define a purpose code like the current indicator. This is optional. Okay, you can define the derivation value. If it is an active record, then you have to put it as Y. If it is an expired record, you can put it as N. Now, these are not fixed values. You can define it as true, false. You can define as A for active, I for inactive, or you can define it as 1 for active, 0 for inactive, or vice versa. Okay, so these values you can choose yourself, what values you want to give in the derivation or the expiration for the current indicator column. And current indicator column is optional. If you define a current indicator column, it would consider this column to select the active records from the table, the SCD stage. If you do not define that current indicator column, then the other important column you need to define is the expiration date. Okay, so many SCD data models, you would see that the way you retain history is using the start date and the end date of the record. The day or the date when the record gets end dated means that it does not continue to exist. There is a new record, updated version of that record that is valid from that particular date. Okay, so most of the time for active records, you would have something like a maximum date value to indicate that it's an active record. For example, let's say 20 or 2999 1231, something like that, which is far into the future. So you have these purpose codes. You can define your effective and expiration dates or start or end date and assign them the right purpose code, effective date and expiration date. If you're giving an expiration date, you have to give a value for the expiration of that date, and this would be the value for the active records. For an effective date, your current date would be the starting date for that effective date. When that record expires, then your expiration date would come into picture, and the expiration date would get updated with the current date. Now, it is very important to give these purpose codes correctly, because this is what would help your slowly changing dimension stage to analyze the data and create the insert and update records. All right, so because now we're doing all this logic using a slowly changing dimension stage, it itself can create the insert and update sequels for your target database, and based on all these columns that you have defined. So now it would look for current indicator column having value Y to identify the latest records from your dimension table and compare them with the incoming source records and so on. Otherwise, it would use the expiration date and effective date combination to identify the active records. Now, the records that it has identified have been updated. It would choose the values you have specified to expire the current record. So it would put the current date as the expiration date. Any new record that it inserts, it would put the expiration date as 9999 which is what you have defined. Any effective date would be end dated with the current date. So if you're trying to update a record, the current record would be end dated with the current date. A new record would be inserted starting with the current date, entering or right, ending with the maximum date which is mentioned over here. So all these purpose codes have to be correctly defined for the slowly changing dimension stage to identify correctly your records that need to be inserted and updated in the target table. Now you should be aware again of what all these purpose codes mean, because these are the most important aspects of a slowly changing dimension. So you can even leave it as blank. That means that the purpose code is default. It has no SCD importance as such, that column. Okay, you can define surrogate keys, business keys, type 1s, type 2s, current indicators, effective date and expiration dates, and a sketching, and so on. Now, what is a CD type 1? You have to be aware it overrides an attribute in a dimension table. No history maintained, the attribute value would be overwritten. SCD type 2, a new row would be added to the dimension table. The old row would be undated with whatever value you specified in your purpose code mapping page. Okay, so you specified the current date as the value that needs to undate it. So you have to, it would be undated with the current date. Each SCD stage processes a single dimension and performs lookup using an equality matching technique. So this statement is important to remember as well. It can process only a single dimension. Each stage processes a single dimension. You cannot process multiple dimensions using a single SCD stage. You can use multiple SCD stages to do that. And how does it perform this lookup? The technique is known as an equality matching technique. You should remember the name of this particular technique. Now, what actually happens in the backend? That is what we need to understand. So those purpose codes that we have defined, the SCD stage would use those purpose codes to build a lookup table for the dimension lookup. If you have defined only type 1 columns, which means all the attribute values to be overwritten, the stage would build the lookup table using all the dimension rows, because you just need to override them. If you have type 2 columns, that means you need to add a new row, you need to maintain history. Then the SCD stage would select only the current rows from your dimension table. So data already exists in your dimension table. You are going to select only the current rows to make that comparison for the type 2 attributes. How does it select the current rows? It first looks at the current indicator column. So it will look at whatever you have specified. So we specified that if the current indicator value is Y, it means it's an active record. It would look for all the records which have a value of Y in the dimension table and take them as the latest records to be compared for type 2 changes. If it does not have a current indicator column, then it would use the expiration date column to identify the current rows from that table. Okay, any dimension columns that are not needed would not be used in the lookup table, and this is to minimize the amount of memory that is required by the lookup table. So this is how it optimizes the whole process, and this is what happens in the backend. So you should understand this as well, that how the SCD stage actually works. Now, when you're updating the dimension table, all your purpose codes would be the part of column metadata that would be propagated to the dimension update link. Okay, you can load it to your database table as well. So these purpose codes can be used for any other purpose. These purpose codes can be used and loaded to your database tables, and you can work based on the values stored in these purpose codes. Okay. And why does it actually propagate it? You might choose not to load them to your database table, but why do we need these purpose codes to be propagated to the database stage? Because these are the ones that the stage uses, or the database stage actually uses, to build the auto-generated SQL option to identify the inserts and updates. Okay. Another important thing you need to remember around the CD stage is that the purpose codes are part of the column metadata, and they are propagated to the dimension updates link. Okay, so these are some important things you need to remember about the CD stage. What are the purpose codes? What are the meanings of the purpose codes? One SCD stage can process a single dimension. How does, and it uses the equality matching technique. How does it build the lookup in the backend to process the updates and inserts for a dimension? And purpose codes are part of the column metadata that are migrated or propagated to the dimension update link and are used by the database stage to auto-generate SQL for the inserts and updates on the dimension. Okay, so these are the important things you need to remember about the SCD stage. Okay, so a sample question around the SCD stage, which slowly changing dimension stage statement is true. So they have given multiple statements. The first statement is surrogate keys are used to join a dimension table to a fact table. Oh, nothing doesn't seem right. Each SCD stage processes multiple dimensions and performs lookup using an equality matching. So it does perform lookup using an equality matching, but it does not process multiple dimensions. One stage can process only a single dimension. So this is also incorrect. Third option is purpose codes are part of the table metadata that the SCD stage propagates to the dimension insert link. So this is also not correct because it propagates them to the dimension update link. Actual dimension changes are applied to the lookup table in the metadata and are mirrored to the dimension update link. No, so this is also not correct. Okay. Okay, so none of the statements seems to be correct actually over here. This should have been an update link and then you would have got a correct answer to this question. Okay. Or this should have been a single dimension. So okay. So this question is not correct. There are no correct answers over here. If it would have been a correct answer, now they've highlighted second option as the correct answer, which is not the correct answer because each SCD stage can process only a single dimension. So this should have been a single dimension because this mentions multiple here. That is why it is not a correct answer. This could have been the correct answer. C, purpose codes are part of the table metadata that the SCD stage propagates to the dimension insert link, but it is propagated to the dimension update link. Okay, so the options here are not correct, but in the certification you would get a correct option. So just look at those key statements that we have read about the SCD stage and you can answer based on those. Okay. Now, another stage that can perform a same function, which is to identify insert and update records for updating, especially a slowly changing dimension table, is the change capture stage. So this was used widely and this is still used widely. Okay. So some important properties of the change capture stage are here. Okay. So how does it actually work? You specify a key column. So key columns are the keys based on which your comparisons would be done. So key columns would identify your unique records. So this is something like a business key over here, right? Then you have identified your change values. So band and department ID. So here you have identified that whatever columns or attributes you mention here, and you want to change, you want to see if any value change for any of these columns. Okay. So that would be your updated value. So these are the columns that you want to check on your values on. Now in your source, you might have 10 other columns as well, which you do not care and you do not want to check the value for. So you do not need to include them over here. Whatever are the columns you want to check the value for to identify the insert or update record, those are the ones you should include here. Now, even if it's a type 1 or type 2, you have to include them here because even if it's a type 1, you need to update the value of the record, right? Now you have these options over here which are very important. First thing you need to understand is your change mode, explicit keys and values. So we want a change key to be generated, which would let us know if the record is an inserted record or it's an updated record or it's a deleted record or it's just a copy. So copy basically means same record as it is. Okay. Now these are various options. Copy in terms of slowly changing dimension, we do not need to do anything with the record that has not changed anything in its value. So these options can be set accordingly. So drop output for copy, we do not want that record in the output because we're not going to do anything with that record. So we'll set this to true over here. Drop output for delete. There's some records which have been deleted in the source. Okay. So do you want to mark them as inactive or you want to do some processing with them? You can set it to true or false accordingly. Drop output for edit. Now this is the most important option. Obviously, edit is basically any updated record, so we want that record in the output because we want to make the updates. Drop output for insert. Insert basically means any new records which are coming in the source, so they need to be inserted as new records, so we want to propagate them to the output of the stage, so you have to set this to false. Now, the codes that would be generated would define whether the record was inserted, updated, deleted, or copied. And those, based on those codes, we would define a logic or partition the output from the stage into an insert dataset and an update dataset that we would use to update our target slowly changing dimension table. So these are the different values that are valid for the copy code. So you have a value for copy code, you have a value for deleted code as 2, you have a value for inserted code as 1, then you have your value for edit code. So these are different values. You just need to remember those values and then frame your logic in the next stage to identify the inserted and the updated records. Okay, or the deleted and the copied records if you need to handle them as well. Okay, so questions around this would be like, assume you have before and after data sets and want to identify and process all the changes between the two data sets, assuming that the data is partitioned and sorted, which of the following should be used. Okay, so your thing is that you want to identify all the changes. Okay, so whenever your change capture is basically a stage that compares your data from the before data set and the after data set. Your before data set in terms of a slowly changing dimension is the existing data in your slowly changing dimension table. Your after data set is a new data that is coming in for loading into that dimension table or updating in the dimension table. So change capture stage basically compares these two data sets, identifies the inserts, updates, deletes, and edits, and assigns them a change code. And that is the code that we use to identify the inserts and updates in our dimension table. So any comparison between before and after data sets has to be done using the change capture stage. So change capture stage would be your answer over here. Okay. Change apply is used when you want to apply those changes. So when you already have a data set that has been processed using the change capture stage and you want to apply those changes further on. Okay. So your correct answer here would be change capture. Now, aggregator stage you would have used almost all the time whenever you have to perform any summations, any aggregations. So an aggregator stage would be used. Now you might already be aware with this interface of the aggregator stage. You have a grouping key. So if you want to calculate the sum of all employees by the department, then your grouping key would be your department ID. You have different aggregation options. You can count rows. If you're counting rows, then that is the only option that you can have. You can have no other aggregation type in that aggregator. But if you are doing your calculations like summing up, finding the maximum, minimum, and so on things, then you can have multiple options in your aggregations, multiple aggregations defined in the same aggregator stage. But when you are using a count rows option, you have to use a separate aggregator stage which can only have this aggregation option, which is count rows. Then you can define your count output column. Count output column always has a default output of double. You have to remember that. And you do not want that in your target stage. You have to manually map it to some other data type, which can be a decimal or something. So you have an option over here to override the default output data type, and you can set it to decimal or whatever is your requirement. Now, the important thing that I want to highlight over here is your method, which could be hash or sort. And allow null output is false over here. So allow null output can have values of false or true. Null output is that if there is any value that is null in the source, do you want it to be output, the result to be output as null? Then you have to make it as true. If you do not want the result to be output as null, just ignore that null value in the source and perform the remaining computation. You have to set this to false, okay, which is what it is by default. All right, now hash or sort. A key fundamental thing to remember here is that hash mode has to be used for a relatively small number of groups, generally fewer than 1000 groups per megabyte of memory. So you have your data distribution and you have some finite key values. In that case, your finite groups would be formed because you'll be grouping by those key values. In that case, you have to use the hash mode. Sort mode has to be used when you have multiple values for your keys. So you have a large number of groups, then you have to use the sort mode. A requirement for sort mode is that the data should be partitioned and sorted by the grouping key. Okay. So use hash methods for inputs with a limited number of distinct groups. Distinct groups are basically key values. Uses 2K of memory per group. Calculations are made for all groups and stored in memory. And that is why a hash table is made in the backend. Okay. Incoming data does not have a requirement to be pre-sorted. Results would be output only when all the computations and calculations have been made. That is why it is important only for to have small number of distinct groups so that uh, the processing could be optimized. Useful when the number of unique groups is small. So this is your key point over here. Hash partitioning when the unique number of groups is small, because the output would be produced only after processing all the groups and records. Sort method to be used when there are large number of distinct key column values. Because there are large number of values and lots of processing is happening, therefore your data needs to be pre-sorted to make it faster. Results would be output after each group computation happens. Okay, unlike in the case of hash method where the results would be output only after all the computation has happened, so can handle unlimited number of groups. Another data transformation stage, funnel. So it's a very fairly simple stage. The important thing you need to remember here are the funnel types, and there are different types of funnel types: continuous funnel, sequence, and sort funnel. Continuous funnel combines the records of the input data in no guaranteed order. So it takes the input record from each link in turn. If data is not available, it skips to the next. So there is no finite or confirmed order in which it would collect your data. Sort funnel would combine your record defined by the key column value. So you can sort based on the key column values and then you can collect your records. And sequence is it collects from the input data set, first input data set, then the second input data set, and so on. So it collects from the first link, then the second link, and so on. So this is especially important like in cases when you have a header record, a data record, and a footer record. So you want the header record to be first, so you can specify your order like this, or you can create a key value and you can sort it by the key value. So to the header records you can assign a key value of 1. To all the data records you can assign a key value of 2. To the footer record you can assign a key value of 3, and then you can sort it. Use this particular mode to sorry you can use the sort funnel mode and sort by the key value 1, 2, and 3, and it would collect the records in the right order. It would be faster as well. Okay, FTP stage, file transfer protocol. So many cases your source system would be files. Okay, it would be a file system. So your IBM systems are sending you files that you need to process as part of your data stage processing. So how do you receive those files? So those files have to lie on your Unix server or Linux server if your data stage is installed on that, and you need a way to receive those files. So FTP is basically accessing files from a remote host, and there's a stage called the FTP enterprise stage which can be used to actually transfer these files. Okay, so you can transfer from a remote host, you can transfer multiple files, you can also receive multiple files, and you can also send multiple files. Now this is how an FTP enterprise stage looks like. You have a source, you just have to mention your universal resource indicator over here, which is the URI. It is something like your path from where you want to FTP the file. You have to mention your credentials that you need to use to FTP your files, your transfer protocol. It can be FTP or SFTP, which is a secured file transfer protocol. Your transfer type could be binary or ASCII, right? So these are the features. The FTP Enterprise Stage transfers multiple files in parallel. Okay, it invokes an FTP client program. URI is Universal Resource Identifier. You can use an open command if you want to perform any other operation, and just you do not want to transfer. You want to touch a file over there before you transfer or something like that. Then you can use an open command. You can put your FTP command if you do not want to use your default FTP command. You have to provide your username and passwords. Your transfer protocol could be FTP and SFTP. SFTP is the most secure transfer protocol. You can have set these options: force parallelism to yes, override to have any existing files overwritten by this stage. Okay, so while we're speaking about FTP enterprise stage, so it is good to know what are the features of the FTP enterprise stage and what are the capabilities of the FTP enterprise stage. Having said that, it is also easier to FTP using Unix itself, so you can use that. And many projects have a separate FTP client altogether, or FTP third-party software altogether that they want to use and not use FTP enterprise stage. Okay, so practically speaking, FTP enterprise stage might not be that commonly used because you have a separate third-party program that, because the FTP is not just for data stage. If you have an organization, you have multiple systems which need to transfer files across themselves continuously. So it could be a third party thing altogether and not something that you need to handle through Datastage every time. But if you do need to handle it through FTP and you do not want to do it through Unix commands, then FTP Enterprise Stage is one option that you have. And also from the certification point of view, you just need to be aware that the stage exists and these are the features of the FTP Enterprise Stage. Okay, now moving on to persistent storage once again. A file connector stage. So again, this is one of the stages that you might not have got a chance to use as a data stage developer, especially if you're not working with big data. So this is a stage that allows you to connect to Hadoop systems, and you also have a big data file stage that can connect to Hadoop system, but this stage allows you to connect to the Hadoop system through some specific clients, which we'll just see. So this is how the file connector stage looks like, and you just need to define your file system over here in the connection properties. It could be local, and these are the two ones: web HDFS or HTTPFS. These are the two ones that this stage particularly allows to use to connect to the Hadoop file system. So you can just define your file name, exclude any files, your reject modes, just as in case of a sequential file, any kind of delimiter that you might have specific to big data, and other properties which are specific to big data. So just okay, so web HDFS and HTTPFS. These are the ones I'm talking about. Okay, so just make a note of these two. Okay, so job control and runtime management. Once again, going back to this particular section, and this has, okay, so basically going to persistent storage and talking about something called balance optimization. So there might be questions around this in the examination as well, because this is mentioned as one of the topics in the certification course content. So balance optimization, first thing, it's a license add-on to Datastage. So you need to have a license to have balance optimization. And I think there is some change. Um I think there's some change in 11.7. I think it now comes as part of Datastage. So I'll just, I think I've covered it in my video on the new features of Datastage 11.7. I'll just check it once again and put it as a note to you when I am distributing the study material. But it used to be a license add-on to Datastage. Okay, so balance optimization, as the name suggests, it is an optimization technique which is like automated by Datastage. So you design a job and ask Datastage to optimize that job, and Datastage uses some of its principles to try to optimize that job. Okay, so it has a limited number of supported source and target stages. So these are your supported stages: DB2, Oracle, Teradata, Netezza, and so on. Sequential files are not supported. Optimizing principles, it runs on certain optimizing principles, which is minimize I/O and data movement by pushing processing back to source data server. Okay, and take advantage of optimizations available in the source or target server. So basically, it is pushing all kind of activities, any kind of optimization that can be performed in the source server itself to source server. Any kind of activity that can be done in the source server itself to source server, so that there is minimum I/O happening, minimum interaction happening between the source server and the datastage server, and that would optimize your job. Again, any optimizations that can be implemented in your target stage or target server would be taken advantage of. So it is not enabled by default. You need to enable it when Datastage is installed, and Information Server Administrator can activate it using the ASP server. When this thing, these are your example commands that you need to activate it. Okay, so what is the workflow and what happens in the background? You build a Datastage job. Okay, so the job that you need to optimize, you have to keep certain things in mind. You have to use default values for stages wherever possible. You have to use the auto generate SQL option in the connector stages. You do not need to use the RCP, and you do not need to include any unsupported values like the stable sorts. So these are not supported. So this is the kind of job that you can optimize. You cannot build a very complicated job and ask Datastage to optimize it, because many of the things are not currently supported. Then you can go to the job, click on file and the optimize option. There's certain options that you can choose and run the optimized job. So the thing that they're trying to do here is that you have built an unoptimized job, okay, using all these hints that we had, that use auto generated SQL in connectors, do not use RCP, do not use any special characteristics like stable sorts or so on. You have run that job, then you ask Datastage to optimize it. Now you have an optimized job and you run that job. Then what you need to do is you need to compare the performance of the two jobs. So the underlying thing over here is that an optimized job might not always be a better performance job. So Datastage might not have been able to optimize it in the best way. So you have to take that decision by comparing your unoptimized job and the optimized job. So your options are which you can yourself uh, even specify is push processing to data source, push processing to data target. So you know your data source and data targets, which has more capability, which has more parallel processing. So you can specify these options based on those that information. Push data reductions to data targets. So any constraints, filters, use bulk loading at the target, which might be very advantageous actually, and push all processing into the target data server. Okay, so they do not obviously always perform better, as we have already discussed. Okay, let's look at this example and then you would understand way better what balance optimization actually aims to do. So you have an unoptimized job, you have an employee data source over here. So you're extracting data from the employee table. Then you're using a sort stage to sort this data by employee last name, and then you're putting this into a sequential file stage, which is your target stage. Now, sequential file stages are not supported by balance optimization, so there's no optimization that would happen at the target level. Okay, so what is this going to do? Your optimized job, you can even go to file, optimize window, and you have advanced options over here, and you can select any options that you want to select, and then just click on optimize. Now what the optimized job would be is that the sort stage has been moved in the optimized job. So you can see the optimized job over here. The optimized job has a source stage and your sequential file as a target. There's no sort stage over here, because what has happened is it has included the order by clause in your source stage itself. This is always advantageous, because it is much faster in your source than doing it through an explicit sort stage in your data stage job. That is one fundamental principle of improving the performance of any job, applicable to all jobs, all levels of data stage development. So even if you are going and trying to design a data stage job which is reading from your source database, or any database table and you need to perform any sorting, please do it at your source level. Any kind of joins need to be performed, please do it at your source level, because the source database is faster in doing all those calculations than Datastage, and it also saves a lot of IO and sorting and partitioning efforts which are needed for these stages. Okay, so this is how it is optimized the job, by removing the sort state and doing the sorting in the source database itself. So this job is obviously going to be faster, but this should have been a best practice, and while designing the job itself, you should have kept this in mind, that there's no need to use an explicit sort over here. You can do the same sorting in the source stage itself. And it, because it has optimized the job, so this is an automatic process that has happened. Datastage use clicked file optimize, Datastage generated a job that was optimized, and if you go to the source stage, you will see that an order by clause has been added over in the source SQL, and it would log all this in the optimizer window and so on. Okay, so this is what balance optimization is all about. You should have an idea about what is balance optimization. It pushes the operations either to the source server or the target server, okay, to minimize the IO. So just keep in mind the underlying principles that it uses, and then you'll be able to choose the correct answers in your Datastage certification exam. Okay, so again, going back to job management and deployment, some user management, basic user management that you should be aware of. So if you need to change any passwords, there's something called directory admin.bat or directory admin.sh. It is also mentioned as one of the things in your certification course content. So you should be aware of what is directory admin command. So it basically sets your password for the user. You can use it to change password or update passwords or set passwords for a user ID. Okay, and these are your different options that are available. So password specifies the user password that you want to set. User ID specifies the name of the user whose password needs to be reset, and command line option that specifies that this task is to work with user. So this is the syntax that you follow. On Windows, it is directory admin.bat. On Linux or Unix systems, it is directory admin.sh. You should know this. This is one thing that they have mentioned as one of the topics in the course content. So you should make sure that you read this before you go for your certification. Okay, now this user management or changing password can also be done in the IBM Information Server Console. So this is how the Information Server Console looks like. Only thing you need to do is go to the administration tab, and then you have an option over here to change your password. So you can just click on it and change your password. So the same thing can be done over here. The only thing is that you need to have admin privileges to perform this option using the information server console, right? Okay. Now there's also something called the encrypt command. The encrypt command that can be used on the command line as well, and it is basically used to store the credentials in an encrypted way. So you do not want you want your passwords to be encrypted, right? So this is the command that does that. Running the encrypt command with the text provided on the command line. Okay, so these are different ways in which you can run your encrypt command, and you can also run it to give you prompts to hide the text. So enter the text to encrypt, enter the text again to confirm, and so on. Okay. So the encrypt.sh or the encrypt.bat script can be used to do which of the following. So it is basically used to set up credential files used by the dsjob. Okay, that is your answer. So it's credential files, encrypt.sh to encrypt user credentials, encrypt the passwords that the user credentials uses. So this is your correct answer. Okay, sequencers. Now, sequencers are another important topic and also very important. If you are a Datastage developer, you might have already worked on sequencers. So sequencers give you a variety of activities that you can include in your sequencer job and work with. So you have end loop activity, execute command, nested conditions, routine activities, start loop, user variables, exception handler, job activity, notification, sequencer, terminator activity, and wait for file activity. So this particular window has different activities on it. These are the job activities where you can just call a job to execute. So you can define a job name over here, and you can pass parameter values to that job name, and that would execute. You can link its output tabs. So you can define triggers on its output tabs, and if it fails, it goes to the terminator activity. If it succeeds, it goes on to execute the next job. Okay. Then you have a user variables activity wherein you can define your user variable parameters. So you can define some constant values, some directory paths, and use them across the stages over here in the sequencer job. You have the loop activity, so start loop activity and loop activity. So you can define a loop and do some kind of processing multiple times. Okay. Then you have the notification activity. So if your job fails, you want to send an email to some particular team that this job has failed, you can use this notification activity to send emails. You have the wait for file activity. Wait for file activity would if you have incoming files that you want to process, it would wait for like 5 seconds, 10 seconds. You can define the timeout and read those files. You have a sequencer activity over here that can take in all the different inputs, and if any of the input is correct, it would pass on the control to the next stage. So you can define if you want all these jobs to have completed for the processing after this stage to happen, or if you want any one of this link to succeed, and then you want the process flow to pass on to the next stage, and so on. So this is a gist of what we just saw. Job specifies a server or parallel job. Routine can be called. Execute command specifies an operating system command to execute. Email notification excuse me, specifies that an email notification is sent at this point of the sequence. Uses SMTP. Wait for file, waits for a specified file to appear or disappear. Now, exception handler can be used. So if you do not want to handle them, the exceptions per job level, you can just use an exception handler, and if any job fails, that exception would be caught by the exception handler. If you are using a terminator stage, it would abort all the other jobs as well, or it would abort the sequencer at least based on the options that you provide in the terminator stage. So in that case, you need to use a terminator stage, and exception handler stage would not cleanly stop the job. Nested conditions to branch the execution of a sequence depending on a condition. Sequencer allows you to synchronize the control flow of multiple activities in a job sequence. Terminator allows you to specify that if certain situations occur, the jobs being run by a sequencer are shut down cleanly. Then you have the start loop and the end loop. Use these two stages together to implement a for next or for each loop. And user variable allows you to define variables within a sequence. These variables can then be used later on in the sequence for other parameters, right? So just go through all these and what these mean. Now, important options in a job activity is the execution action. You can choose all these options. You want to run your job, you want to reset your job if it has failed, reset if required, and then run. You just need to validate your job or reset only. So these options can be chosen. And why is the sequencer important? Because it provides us restartability capabilities, because it adds checkpoints if you enable that option at the job properties window, and from it can restart from the point of failure. So that is the importance of a sequencer. Now the loops which we saw, the two types of looping are possible in those, numeric and list. Numeric would be for counter 1 to something, and you can define the incremental differences, and list would be for each thing in a list. So you can define a list like US, Canada, Mexico, and so on, and the processing would happen for each country. So you can define that list, and the loop would go over each country and do the same processing, right? Now, another important thing is the triggers tab in a sequencer. So a conditional trigger can have these values: OK, failed, warnings, return value, custom, and user status. And based on these trigger values, you can define the flow further down. So if it is OK, then you can define a particular link to be active. Failed, if it has warning, if it returns some return value, if you want to put a custom statement or a user status. Unconditional is that trigger would be fired on that link, and that link would be active unconditionally. Okay. It won't matter if the job failed or the job executed successfully or if it had warnings. Okay. So this is where you specify the triggers. You specify your job over here. You specify your triggers over here. And these are the various things that you can write. If you're writing a custom condition statement, you can check the job status as 0 or 1, false finish with warnings, or aborted. So you can specify your activities like that. Right. Again, there's a detailed video on sequencer, which I would provide you a link to. So if you're not clear with the usage of all these stages, you can check out that video. It's already on a YouTube channel, and it properly describes all the sequences and all the activities that can be used as part of a sequencer job. Okay. So another important thing here is a DB2 stage or any kind of database stage. Okay, so we have not covered anything regarding the database stage, but the only important thing that we need to know surrounding the database stages is the record count and the array size. Okay, so array size can have values like this. You can define your buffer size, you can define your record count. These basically define the batch size of the transaction. So how many records would be inserted in a transaction, or how many records would be inserted in a batch, and that defines how fast your data processing would occur. So it is basically defining how many records would be included in an input output operation. Okay, so they have to be multiples of each other, array size and record count. You also have an option to set the record count to 0. If you enter 0, that means the connector processes all records before it commits the transaction. So if your processing is really slow because a commit might be happening too frequently, and you do not care about all the records being written, so you do not care if any error occurs, you do not want any commit to happen, you can set this to 0 so that your operation would become faster, because now all the records would be committed only after they have been processed or read by that source stage or written to that source target stage. Okay, if you specify some particular value, let's say you specify 1, then it will be very slow, because after every record that is read or written, a commit would be fired, and therefore you have increased your input output operations, and a commit is being done every time, so it would decrease the performance of your database stage. So this combination of values and these three properties are the most important properties with regards to a database stage. So record count property is set to 0 in connector stage. How many records are written out? So all rows are written out, because only then a commit would be done. Okay. Okay, so another important aspect and one of the topics in your certification exam is designing jobs as services. So you might not have done this. Information Services Director is what you need to use to run your jobs in real time. So you can run your jobs as service. The service is your Information Services Director. Okay, so you can define your jobs in different formats. You can define your batch jobs. They have all these different characteristics that you need to understand, and then this is how it looks like basically. And these are the stages that you use. ISD stages, Information Services Director stages. You can have ISD output stage or an ISD input stage. And this is using an ISD input stage. So what is happening here is basically a real-time operation is happening. So there is a customer who is entering his account number, and you want to output his account details to him instantly. So this is a real-time operation. How can you make it happen through data stage? If you want to make it happen, you have to transfer that service request with his account number through the ISD input stage to data stage, and then data stage would fetch the details of the account number and transfer it back to him as a service response. This is basically what is happening. And these stages are running on Information Services Director, because that is what can run the stages as service. So it is actually passing your request between the different servers, passing it to Datastage to fetch the results and pass it back to the client. So if you have these requirements to run it real time, run your Datastage job as a service, then ISD input and output stages are the ones that you need to use. You have to remember all these design and runtime constraints. Here, a job that has an IC input stage and a data source stage with input and output link does not work. So if you have an IC input stage, we do not need any other data source stage in the job, because if you have that, then the real-time processing would not be possible, because that input stage would need to wait for reading the records. So some IO processing is happening, so that would impact the real-time performance. So any real-time job you're designing, use only a single ISD input stage, no other data source stages. Okay. So multiple job instances are possible with these real-time jobs. So you have to actually analyze your resources and make them available for all these requests that might be coming. So there are multiple people entering their account numbers at the same time. You have to fetch them their account details, and there are multiple requests coming at the same time. So concurrent use of resources is happening, and you have to make sure that your resources are available and are of that much capacity to meet all these requests. These are always running instances. Okay, so you can have these instances running 24/7. So your resources should be really uh, matching enough to perform this real-time performance. Okay, so timeout values and so on. So you cannot use job parameters for buffer size and timeout. For ISD output stage, you have to have fixed values that the ISD can use and read and access beforehand. So do not use job parameters. They cannot contain more than one ISD input stage or more than one ISD output stage. Okay. This is the thing that you need to remember. Real-time jobs cannot contain more than one ISD input stage or more than one ISD output stage. So questions around this, so you'll have to read that in detail. I know that you would not be using those stages that much. Real-time processing using data stage is rare, and if it is done, it is not always done using the ISD stages. There are other ways of doing it using database itself, using materialized views, and so on. So this is not one of the topics that you would have got any hands-on on. Very difficult to get hands-on on this topic, so it's difficult to understand what are the capabilities of those stages. But just remember in short that how many IC input and output stages can a job have, what are the constraints that you need to consider. So no job parameters, consider multiple instance requirements, and so on. No other data sources in the job allowed, and so on. So just remember these features, how many input links, reject links, all those things it can have, something like that. And how it actually works in the backend, that is thing that you need to understand. So which of the following statements about real-time job design is true? So you'll have a question like this. And now here I've posted something from the IBM website, and it is based on this particular statement. So just read this introductory part for these stages or real-time processing. The IBM InfoSphere Information Services Director server starts job instances on one or more InfoSphere servers for load balancing and scalability. So that is something which is a statement that is given as an option in this job. So which of the following statements about real-time job design is true? Okay, so the information services director server starts job instances on multiple database servers for load balancing and scalability. Okay, so whatever sentences are there actually coming in as options on the certification questions, there are some statements picked from the description which is already posted on the IBM website for these stages. So I'm giving you a feel of the questions that might be asked, so you have to be careful about reading. Whenever you read any information about these stages, any important line that or sentence that you come across, make a note of it so that you can just reference it quickly before your certification exam, and if there's any question around that, you would know. Okay. Okay, so the correct answer would be the Information Services Director server starts job instances on one or more database servers for load balancing and scalability. Okay, So another topic that would be there would be your complex flat file. Now, complex flat file, again, we are going to cover briefly, and I'll be providing you all these slides and study material so you can go through it if you really want to understand it in detail. Because again, mainframe files, a complex flat file is basically for a use for a COBOL file, which is not used that much in the Datastage jobs nowadays, or in any. It is mainframe processing, which is a very legacy system nowadays. But still, you should be aware that this is a stage that exists that can access these files, and these files were actually used a lot a few years back. So it can process data in a COBOL file. File is described by a COBOL file descriptor. File can contain multiple record types. So a COBOL file basically has multiple record types. There's something called the COBOL copybooks with multiple record formats. Columns can be loaded for each record type. On the record ID tab, you specify how each type of record is loaded or formatted. Okay, so all these things, this is basically how it looks like. So you have a client record, you have a policy record, and you have coverage record. So for the same copybook, insurance copybook, you have three kinds of record types: client, policy, and coverage, and they have different structures. So these are the column numbers, record types, and something. Okay. So you can import your metadata, you can define your different items over here. These are how the table definitions would appear in the columns tab. This is your level number. This is your column name, your length, your display. In the layout tab, you can choose COBOL layout and see this is your client. You have these records, these level numbers, name, country. And if you want to edit column metadata, your date format, you can choose a data mask, something called a data mask. Record type 1 is client record. Then record type 2 is policy record. Record type 3 is coverage record. So this is how you can identify the different multiple formats. This is how a job looks like. This is your CFF stage, reading through it, and there you have separated the three record types: client, policy, and cover. Okay, client, policy, and coverage here. So these are the various properties that you can define. Okay, and to process these multi-format records, if record type is 1, then it is a client record. If record type is 2, it's a policy record. If the record type is 3, it's a coverage record. Using this, you can separate out the three record types. So you can take a look at this video to see what are the different options in the complex spread file. So this is how it looks like. You can go to stage, general, then you have the file options. You can use file pattern, source list. You can define your file name over here. You can define your record type to be fixed block, variable block, variable span, all in reference to a COBOL copybook. Missing file mode is same as in sequential file almost. Project mode is same as in sequential file almost. You can read from multiple nodes, number of readers per node. So even these options are same as sequential files. You can report progress, keep file partitions, and so on. So these are the various options. Then you have record options where you can choose your byte order, you can print fields, you can choose your character set as ASCII or Abcdec. You can choose your date format to be text or data format to be text or binary. You can choose your record delimiter. You can choose your decimal values, separator if you want, allow all zeros. You can define your default values and so on. And if you go to records, so you would see your records as we saw there, like the three record formats with their level numbers: policy, insurance, and coverage. Record ID, layout, you can choose parallel or COBOL. If you choose COBOL, you will see it that way. You can define your analyst map and so on. Output would be, you can define your constraints over here. You can define your columns, and this is a default advanced tab as you have. You can go through the fast path options as well, which would take you through the same screens.